Good afternoon, everybody. Welcome to today's post-mission management team press conference. To my left, once again, the chair of the MMT, Wayne Hale. He's also the deputy manager of the Space Shuttle program. To his left, joining us today is Terry Murphy. She is the Shuttle Imagery Integration Manager. And I think both folks will have some opening remarks, and then we'll throw it open for questions. And I'll turn it over to Wayne.
Thank you, Kyle. It's been a very good day today. As you watched, I know there have been a number of events that you've gotten to participate in. The orbiter Discovery is working flawlessly. The crew is performing very well and is in great spirits. And I know that during the mission status briefing earlier in the day, you heard all about that. I wanted to tell you a little bit about the mission management team meeting. We practiced many simulations with the mission management team where the training team put together difficult problems for us to solve, and sometimes our meetings ran rather long. One memorable mission management team meeting ran 6.5 hours, which is, for those of you that may have heard about or participated in those meetings before the accident, they just didn't last very long. Today, given the level of work going forward, we were done in just under 2 hours. That is not indicative of not paying attention, but it is indicative, I think, of the level of things that we've got to pay attention to. We had a very good summary from the tile folks, the thermal protection system folks, and what they've seen in the focused inspections and their analysis of the photography that was taken as we approached the space station. They've cleared a number of areas. We're feeling very good about Discovery coming home. But I've got a couple of videos and pictures to show you, and we can talk about those things a little bit more. So let's go ahead. First, we got a couple of video clips. These will be the films, videotapes actually, that we recovered from the solid rocket boosters, looking at the external tank during ascent. We'll see one from the left, one from the right, and then the combination shot. Here you see it's not a very exciting view. You can see the orbiter black down at the very bottom, the Earth glowing brightly underneath. In just a second, we'll have the solid rocket booster separation, and you'll see the flash and the other booster come into view. We're seeing the solid rocket booster burn out and the flickering of the light, and there we go. Tomorrow, we're going to play the whole tape from launch through splashdown for you from both sides. Now, this is the other booster, I believe it is. The interesting thing is if you look at the top of the screen, you're seeing little white pock marks come on the external tank foam. That is a phenomenon known as popcorning. We're losing little pieces of foam off the tank. The side that is away from the Space Shuttle orbiter. The side that's toward the Space Shuttle orbiter, well, we actually saw the same one twice, Nancy. So we'll see, I hope the other side, which will be inverted, you'll go ahead and run the second clip. There you go. So now it's mirror image to the orbiters at the top. And what you'll see is the side of the tank that's toward the orbiter, we drilled hundreds of little holes in the foam to ventilate the foam so it doesn't come off. So those little puck marks are coming off on the side away from the orbiter, and if you look on the side toward the orbiter, you don't see any of that occurring. Okay, and then we have the composite shot. These are time synchronized, so and away we go. Okay, that's fun, and as I said, we'll show you the whole video from launch to splashdown tomorrow. Let's see. Next, I have a picture that we got from on orbit. This is a picture of a gap filler poking out, I believe. Yep. Nope, this is the picture of the main nose landing gear tile damage. Thank you. This is from the 800 millimeter pictures, which we have now gone off and done what we call a focused inspection using the LCS sensor to look at that, and we now know very accurately the entire size, shape, and location of that damage. It's 3/4 of an inch long, about 3 inches wide, and the depth is about 1/3 of an inch. That depth is such that the thermal barrier, which is the thing I think we're most concerned with, that surrounds that door opening, is below the damage depth. So that's very good news. The engineers are off running a thermal analysis of entry with this size damage, but given that the thermal barrier, both thermal barriers, but the outermost thermal barrier in particular is below the depth of this damage, I'm feeling very confident that this is not going to turn out to be anything of significance for us to be worried about. But as I've told you several times before, there is a process, and the engineering analysis will come back and tell us the results of entry with that size damage. Next picture, please. Okay, yesterday I showed you a picture of a gap filler, and going through the data, all the pictures, we found yet a second gap filler protruding. I'm going to talk a little bit about gap fillers at the end of this, but we have actually two now, and this one is also in the nose area on the right-hand side of the vehicle. The other one is the nose area on the left-hand side of the vehicle. So it's a little white thing sticking out by the black tile. Just a little edge sticking up, as you can see. Next picture, please. This is a historical map. We have had gap fillers come out before. These little spots are the history of significant protruding gap fillers that we've had. These are little things that go between the tiles. The thing that is of interest is they disturb the aerodynamic flow in the underside of the vehicle, and they can lead to increased heating downstream or toward the back end of the shuttle. And so when we do our thermal assessments for entry now, because we've got these two protruding gap fillers, one on the left and one on the right up near the nose gear door, we now expect to have a little bit higher than normal, but within what we've seen, heating, and the engineers are off running the detailed thermal analysis for this weight, this orbital inclination, this entry trajectory, and so forth. Now, what we've got are a bunch of little squares showing the location of gap fillers that have poked out from time to time, grouped by the flight. So if you take a box, one of those label boxes that's got 2 or 6 or more little numbers in there that you probably can't read, and we're going to post this on the web page so you can see it, by the way. That's all off one flight. And so this is the historical database. And these have caused our boundary layer, and we can talk about boundary layer transition from laminar to turbulent flow all you want to this afternoon. These are the ones where we had early boundary layer transition, that is to say, at Mach numbers higher than Mach 12. And the thing of interest, now that we've gone back and looked at this historical data, is there appears to be something going on immediately aft of the nose landing gear door, and we're going to have to go off and think about why it is that we have gotten a number of gap filler protrusions off a number of flights in this area. And perhaps there's something about the way the tiles flex, perhaps there's installation procedure that we need to look at. We don't know today, but we are obviously going to go off and look at it. The thing I want to talk to you about gap fillers coming out is that they are not caused by impacts. This is a failure of something to stay in place that is not caused by an impact. I think that's the last picture that I've got. I've got a couple of show and tell. This what I have in my hands right now, what we call Ames gap filler. It's a fabric cloth, ceramic cloth material. You have to get the experts to tell you what it is, but it goes between tiles. So normally On the underside of the orbiter, the tiles butt up so closely together that we don't need anything between the tiles. As a matter of fact, you want to allow a little space for thermal expansion, but there is a gap that once you exceed that allowable, you'll put a gap filler in, and they will cut it with scissors, and there's a procedure to actually insert that and then hold it in place. The one that we showed you yesterday is not technically a gap filler. It's called a ceramic okay, my mind's gone blank. It's shim, thank you. Ceramic shim, which is for bigger gaps. This is the same material that the tiles are made out of, and they will again cut that to the right size. This particular shim is 80 thousandths, that's 0.080 inches thick, and that's the one that, if you'll remember the picture from yesterday, we saw poking out. Let me see, I can show you the white side, about to this much. So, you know, if you were flying a regular airplane and you had a little piece of something sticking out from your airplane that much, you wouldn't think anything of it. But when you're flying, you know, Mach 20, that's something significant you want to look at. It's not a damage in the sense that we've been talking about damage, but it does have to do with the performance of the thermal protection system and the heat that's going to encounter during entry, and so we're going to analyze it and think about it. I also showed you, I think, a picture yesterday, the little blanket under the window that's come loose, and folks are off doing a similar kind of analysis to look at heating in that area. But all of these things, at least in my estimation, are not serious in the sense that they don't cause us immediate alarm. They are part of the process that we are going to go through and absolutely understand with engineering rigor and analysis how the system is going to perform during entry with these items. Also today, I need to tell you, at the mission management team, the International Space Station formally requested that we spend an extra dock today with them to do some additional work, some transfers, and so forth. They have started putting together a list of the additional things they'd like to have transferred. It appears that tomorrow we will have formal results from the consumables that will allow us to formally declare we have that capability, and at tomorrow's mission management team we will formally consider whether to extend the dock period and the whole flight. Thereby by one additional day, and I expect that is what we'll do. Tomorrow, I think we're going to bring Bill Gerstenmaier over, and he can tell you a little bit about what's going on with the International Space Station and why we wanted to stay an extra day, and so forth. We gave a go for the EVA. Steve Doring, who's the head of the EVA project, was happy to say after 3 years he's proud to give a go for EVA. Mission management team is ready for the first American spacewalk in some time, and we're all excited about the tasks that are going to be performed tomorrow. And the International Space Station team is, in particular, happy with the prospect of regaining one of their 2 non-functional control moment gyros, which is one of the several tasks that we're going to do tomorrow. I think I'm going to quit and let Terry Murphy talk to you a minute. I brought Terry over here today. She's the head of the imagery analysis, no, that's not right, imagery integration team, and she has been working for the past several days to get all of this video, all of the pictures, all of the radar information to the right analysts to make sure that it all gets analyzed in a timely manner and handed over to the vehicle damage assessment team. She's going to talk a little bit about that. Terry?
Thank you, Wayne. First, I'm glad to be here today and share with you the process that the teams have been using to understand both the debris environment from an imagery aspect and the damage environment. About a year ago, we were kicked into putting assets in place. We increased our ground camera systems by maybe 25%. We added radars to our suite of debris indications. We put wing lineage sensors on board. we went and put some sensors, laser camera system, and the laser dynamic range intensifier sensors on the end of the orbiter's boom sensor system, and we added wing leading edge sensors. And all of those individual assets have really incredible supporting teams that were working to make those projects come together. But what we didn't really have in place yet was an integrated plan for how we were going to analyze all of that debris indicators and get that information to the people who were looking at for damage and use that information to try to narrow in on where the damage might be. In addition to all of the assets, we also put in some new systems that would move the data from each of the centers. So essentially what we did is we developed an integrated plan that would take all of the ground analysis of the cameras and would lead that into the surveys for the damage. So there's several teams supporting all of this effort. There's teams at KSC, there's teams at Marshall Space Flight Center, there's teams at JSC, there's representations from industry from the NEPTEC and from Sandia National Labs. The teams have inclusions of image analysts, there's subsystems experts for each of the tile and the RCC. So there's a lot of people working to pull this effort off. I'd estimate we probably have 100 people in the image analysis arena just looking at the ascent imagery for debris. There's probably an additional 100 people working the on-orbit inspections and the survey imagery. We have a brand new radar team. There's 30 or 40 people out at KSC that were looking at all of the radar data that was becoming available, and another team of wing leading edge sensor experts. To prepare for that process, Wayne mentioned the MMT simulations. In addition to those, we've done dozens of individual component simulations to prepare for that. We've done many integrated sims, and we were really well prepared and excited to exercise this process. The first part of the process, of course, is the debris analysis or the indications that we were getting from the ground cameras. We put HDTV cameras so that we could move the data quickly to the different centers to get a quick look of what our ascent environment looked like. That data was moved as expected. We had data at all 3 centers within an hour. The teams were busy analyzing it. We were getting our first indications of where we had any debris events. Of course, we had the fabulous ET-LOC feedline views that gave us great early insight into some potential debris events. The cameras on board confirmed that we did have some debris events. That imagery and that process worked exceedingly well. And we are about complete with that discovery phase. The teams are in their last analysis of the films that had to be processed in Miami, so that piece is about done. The radar analysts, they plan about 24 hours of support after a launch, and they go through several levels of screening also. They were able to confirm 5 of the events that we had seen in imagery. They have a bunch of other events that they're also working to confirm. And then we had the wing leading edge sensor system, and that team has also identified some very small above the threshold, however not hoppable impacts, but possible impacts. So we're using all of that data to focus where we looked when we did the analysis. We went out and we did the screening. The screening data came back from both the survey and the RPM. We looked in those areas that we had concern and haven't really seen much spectacular. And luckily we didn't, the site was very clean and there was not a lot to look at. So I guess in summary, I'd just say that the process is going extremely well. We've been able to corroborate several events, and we've met most of our predicted timelines. The teams have done an outstanding job of reacting to little problems that they found in the way and adjusting to make those timelines, and each of our critical decision points were all met. And I think that's all I have.
Okay, great. Ready for questions. We're limited on time today, so please limit it to 1. I have to conclude this briefing before the top of the hour. We'll start right here.
Question for Wayne. Are those gap fillers at all close to the area of the chip tile that you showed earlier? As I understand it, the concern would be if the tile was aft of the gap fillers.
In terms of are they immediately next? No, they are some distance away, 10, 12 inches. So they would not. This won't be an interaction kind of thing between the nose landing gear door, which is the nearest chip, in these gap fillers. The point, however, is that anywhere downstream, that is to say aft of a protuberance like this, you may have increased heating over what you would normally expect. And so any little chip tile, of which we have a few, you need to evaluate that at a higher heat level than you would if you didn't have this. So the interaction is that you increase the air turbulence and the heating to downstream locations, and that's what we've got to go analyze.
Yeah. Jim Alberg with NBC. Wayne, this morning Phil Engelhoff mentioned the remote possibility of considering whether or not some action might be taken about some of the protruding fillers. They are accessible, are they not, from the RMS with the foot restraint? Is any more thinking been going on as whether or not someone should go down there and snip them out?
Well, you know, we never leave anything uncovered. So yes, there is a team off looking at what we might do, not only for the protruding gap fillers, but for the blanket on the side up by the window. Those are EVA options. I think the probability of using those remedies is low, but the team is off putting the plan together in case we come back with analysis that says we need to do that.
Irene Fox with Reuters. Wayne, with one of the major test objectives of the STS-114 flight failed, the tank, could you talk a little bit now about what's going to be on the line for the test flight for 121? And if you think that you might need a third test flight to prove the system is good enough to return to space station construction. And then on a related note with STS-121, I don't know if anything's changed since the last time I asked this, but I'm not understanding why you'd be proceeding with processing and having people working at the Cape to get that shuttle out to the pad when it's obvious you're not going to fly with that tank as is.
We did make the decision over the weekend, or for this weekend, that we would not work people overtime on Atlantis. We think that we had that much margin in the system. We have not released Atlantis from the potential for a launch on need mission. We're probably going to make that decision on Sunday. In terms of processing, they could be ready for a September 9th launch. I think the program is off working to determine exactly what we're going to do. Again, from my standpoint, as the chairman of the mission management team, we're focusing on 114 and what we're doing on this particular space flight of discovery. And frankly, I have not attended any of the meetings or our sessions that are going on as regard to what we might do downstream. So I think you'll have the opportunity at some point in the not very distant future to talk with folks that are participating in that, but I'm not prepared to answer any of those today, Irene.
Dennis Spellman from KHWB here in Houston. Just wondering if permission is granted for the astronauts to spend an additional day at the space station, some of the things that they'll be working on in that extra day up there.
Well, in fact, that's what we're going to review tomorrow. I know the technical teams have been off developing the list. I did not bring them with me because they are preliminary, but they're going to come with a formal list of what they want the team to do. Basically, it falls into additional transfer time, some potential maintenance activities, those sorts of things.
Marcia.
Wayne, besides possibly looking at the gap filler protrusions, are you asking or even considering having the spacewalkers do any other checks outside that have anything to do with thermal protection systems?
At this time, the EVA team is concentrating on the first planned EVA, which starts in the wee hours of the morning. So we have asked them not to do any work on that right now. At the end of the day tomorrow, we're going to get some more engineering analysis of some of these items, and we may come back with a request. But right now, we've asked the EVA team to focus their attention on the first planned and as pre-flight planned EVA that we're going to execute.
You have a question? Yeah,
I'm Ted, Fuji Television. You suggested that none of the tile dings were very serious, and that would suggest that you don't plan on going and repairing any of them on EVA. Is that correct? And also, have you ever gone back to any of those gap filler protrusions in the past and fixed those on EVA?
Well, you know, one of the things that is very important about this flight is that we have added all of these measures, the camera views, the inspection boom, the inspection boom, and so forth, to give ourselves new data. We have never previously detected a protruding gap filler in flight. It's always been after landing. So this is really kind of exciting data. As a matter of fact, the aerodynamicists were a little excited because they've always done these analyses after the fact, and now we know before the fact exactly how far these things are sticking out. So they in some almost perverse sense, they would like to get the data and see how this really occurs during entry. So no, we have never considered pushing them back in before because we've never, in fact, known that we had these until we landed. The other question, I want to go back to process. I want to make sure that you understand the difference between my opinion or my impression or my general feeling versus the process. I have given you a general impression that these areas of tile damage are minor. They are not of significant concern, and I think we will likely come to the conclusion that nothing needs to be done about them. But what is important is that we have a process that is very thorough, that's grounded in testing, that has very good engineering analysis associated with it, that will come back here in another little less than 48 hours and tell us, do we need to or not do something about these. So I would not rule out, I cannot in fact rule out the potential for a repair. I'm just here to tell you that based on what we're seeing and what the experts are passing along to us, it looks very much like these are not areas to be concerned about.
Sorry. Oh, I'm sorry, John. John Johnson, Los Angeles Times. If I remember right, or is the first gap filler that protruded is about 1.5 inches. Can you tell us how much the second one is protruding, and can you compare the height of those protrusions to the history that you showed up earlier on there as to, well, is this larger or less than the others?
Well, the first one was protruding about 1.2 inches, and they got a little bit of an update. I think it was a little bit less than 1.2 inches. I did not bring the height that the second one is protruding, but it's about the same, order of magnitude. And I certainly didn't bring the historical data. We can get that. The problem with the historical data, however, is that it is a post-landing measurement, and what they were sticking out when we started the entry is the important thing, and we certainly don't have that data. We can tell you what it was, after we slapped wheels down on the ground. Did that shake them loose more? Did they potentially melt off a little bit during the entry? We don't have that data.
Kelly?
Kelly Young with New Scientist for Wayne. Can you give me an idea of on launch how these gap fillers are held in place? And then before now, have you ever looked at why there seems to be a concentration of these protrusions after the nose landing gear door?
Well, folks spend a lot of time studying and worrying about the thermal protection system. This is the first time it's been identified to me that we seem to have a cluster that we need to take a significant look at, but I'd be surprised if the folks on the thermal protection system team hadn't previously noticed that and hadn't already thought about it. So if this is in fact something that we newly picked up, then that's interesting, but we're going to go off and deal with it in our process. Now the ceramic shim is held in with what they call ceramic glue. I don't have any real technical chemical formula for you. I have not got an idea about that. The shims also have an adhesive that they are put in with, but they're mostly held in because of the very tight wedge that you got between the tiles.
Where am I? Go ahead, Craig.
Craig Cavallo with Aviation Week, same topic, Wayne. About how much higher temperature have the folks said you could get behind one, and how far downstream would it be?
Well, it increases, technically it increases the heating rate, so it's time and temperature. I have heard the numbers on the order of a couple hundred degrees, and when you're talking, 2,000 degrees, that's the sort of numbers that you're talking about. And it's also how long does that extra temperature stay there? Is it short time or longer time to soak back into the tile and into the structure? Craig, did you know the answer to her question? Because you've been covering tiles for a long time, and I can't remember. No?
Let's get two more here, and then we'll go to Ames and then come back for the 2 minutes we have left.
Patrick Peterson with Florida Today. The film of the external tank showed that you had analyzed and solved the problem of the popcorning. Do you yet have an understanding of the aerodynamic and physical cause of the reason why the large piece of foam broke off the tank?
Well, I have an answer for you, and I'll be happy to give it. No, we got to work on that.
Leo Yang with TV Asahi. Question for Wayne, please. You mentioned about the ISS request for additional date for crew members to remain being docked. I was just curious if that is only simply because they needed additional transfer time, or could that be possibly because they are considering they might need extra time for the repair by any chance?
The repair to the shuttle? No, that was not part of the International Space Station team's request. Their request was from the standpoint of additional transfer and maintenance on the station. Any request to stay longer to do a repair to the shuttle would come from the shuttle team, so that hasn't been ordered yet.
Okay, let's go to Ames out on the West Coast for a question out there.
Eric Rosales, KGO News. Can you just talk to us about the procedure of actually going out there, and then the astronauts will in fact take a look at the pieces, and they will decide, or a combined effort?
Well, no. You're talking about the evaluation of these damage areas? No, this has got nothing to do with the EVA that the astronauts are going to do. The astronauts are going to go do an EVA that's got a repair demonstration for the reinforced carbon-carbon that's done on a sample box in the aft of the payload bay. They're going to rewire one of the control moment gyros on the International Space Station. Let's see, there's 4 objectives, I can't remember, but none of them related to these small damages on the thermal protection system. We're evaluating them using the sensors that we have put in place for this flight, and they're being evaluated on the ground.
Okay, we're back here for any wrap-ups. Does anybody else have any follow-up questions? Or let's get Craig. You might be the last one.
To bring Terry Murphy into the game here a bit.
Thank you.
On the radar imagery, can you discuss anything that is especially interesting? Wayne mentioned yesterday there's an indication maybe you can see the tank resonating of sorts.
Yeah, one of the interesting things that they found was during the ohms assist, they saw a considerable shock wave go through the vehicle, and I don't have any more details on it than that. The other thing is they've worked with us really closely is we've had imagery events, and these are small imagery events. These aren't imagery events that, it's not the power ramp event. Clearly they saw that. But there were also, we see a lot of streaks in the plumes, Tyvek covers coming off, and they've been able to correlate really well with those events.
Does anybody have any final question? Tarek?
Thank you, Tarek Malik from Space.com and Space News. Just a clarification from Wayne about that ISS request for the additional day. When you say that it's transfer related, is that meaning that maybe the crew is behind schedule in terms of their own transfer, or is that a separate type of transfer that's not related to the 114 mission?
Those are additional transfers. The crew is, as far as I'm aware, on schedule and doing a transfer. This is not because the crew's behind. It's because additional items have been identified.
Jim, we'll let you wrap up.
Wayne, just from the ISS request, clearly the additional day is inside the station, but has the ISS folks gotten greedy about other things such as additional tasks on EVA 3, for example, to help them get ahead? Have you heard of any interest they have in additional get-ahead EVA tasks that they would like to time available at the EVA 3?
In fact, Jim, you're right. They did have a discussion that they are considering, have not brought forward formally, to remove a motor that rotates the thermal radiator. I'm not a station expert, so I'm not real smart about these things, but apparently they're having some problems and want to remove one of those redundant motors and bring it back so that they can do a failure analysis on it. I'm sure Bill Gerstenmaier can tell you more tomorrow, and that is they have mentioned that is a potential to be added to the third EVA.
Discovery, and a special morning to you, Soichi. If you had been listening really close to the wake-up music, you might have been able to hear your own children's voices in the choir that was singing.
Good morning, Shannon, and thanks for the great chorus by Japanese School of Houston, and also my wonderful family, Miki, Yuka, Ami, and Niwa. Thanks for the great support over the many years. It's been a long wait, but it's certainly worth it. And today, let's go spacewalk.
And we're all watching Soichi. It's going to be a great day. This is going to be an absolutely fantastic day for you. And your kids are really going to enjoy watching you. And by the way, it's a special day not only because you're making a spacewalk, you and Steve, for the first time, but if you happen to run into the ISS CDR sometime today, you might want to congratulate him because this is the start of his 3rd year in space. He has now had 2 years in space, and this is the start of his 3rd year. So you might want to congratulate him about that sometime today.
We sure will. Thanks.
You're welcome.
Work underway to reposition the space station's robotic arm, the Canadarm2, onto its normal base of operations on a grapple fixture on the Destiny laboratory.
Agree that your plan for pushing FCMS off to Flight Day 7 should work out just fine. So we will make that change, and we'll reflect it on the Flight Day 7 flight plan when it comes up.
Thanks, Steve, and thank you for the flexibility.
On the left side of your screen, you're looking at the truss structure of the International Space Station. On the right side of your screen is the Destiny laboratory. At the very top of your screen is the crew cabin of Discovery. Right behind the aft bulkhead of the crew cabin is the orbiter docking system linked up to the forward docking port on Destiny. The two crews have been together now for 2 days. Hatches are actually closed between the shuttle and the station as they were last night to afford an opportunity for the shuttle to be depressurized to 10.2 pounds per square inch, thus facilitating the pre-breathe of pure oxygen by Steve Robinson and Soichi Noguchi to purge their bloodstreams of nitrogen bubbles that could form and create a condition called the bends when they step outside in their spacesuits into the vacuum of space. This is a routine procedure that precedes all spacewalks to make sure that the crew maintains its health and capability to perform outside. And a good view looking down at the external stowage platform, which is mounted on a pallet about halfway down the payload bay of Discovery. That external stowage platform will be released, grappled by the station robotic arm, and maneuvered to be installed on an attachment device on the Quest airlock during the 3rd spacewalk that's coming up next Wednesday. There is an attachment device at the front of that pallet of hardware called the S-Pad. The acronym is ESPAD, the External Stowage Platform Attachment Device, that will be brought up to the Quest airlock and attached to a set of trunnions today during the 1st spacewalk by Soichi Noguchi and Steve Robinson. Commander Eileen Collins up on the flight deck of the shuttle Discovery, joined by Wendy Lawrence, who is floating back and forth between the flight deck and the middeck, where she's assisting Andy Thomas in helping suit up Soichi Noguchi and Steve Robinson for their upcoming spacewalk. Discovery flies smoothly on, no issues being worked by the shuttle flight control team as Discovery and the International Space Station move from northwest to southeast, having just crossed the equator over the Pacific Ocean. Charlie Camarda now floating into the field of view as well. And the scene shifts to the middeck of Discovery. Charlie Camarda, Wendy Lawrence, Andy Thomas down there as well as they work to assist Steve Robinson and Soichi Noguchi in the suit-up procedures and the preparation of the shuttle airlock for the start of today's spacewalk that is scheduled to begin at about 3:45 Central Time. Downlink television from the shuttle Discovery and the airlock showing spacewalk choreographer Andy Thomas with the two spacewalkers for today, Steve Robinson on the right, Soichi Noguchi on the left. final preparations underway as the crew will prepare to have their helmets put on in preparation for the final pre-breathe and depressurization activities that will lead ultimately to the opening of the hatch and the moment that the suits are placed on internal battery power to mark the official start of today's spacewalk. This will be the first spacewalk for both Noguchi and Robinson. This is the 59th spacewalk in support of assembly and maintenance of the International Space Station and the 26th spacewalk staged from the shuttle itself during the ISS era.
And Houston, EV2, sound check.
EV2 Houston, we have you loud and clear.
EV2 being Steve Robinson, EV1 Soichi Noguchi.
Yeah, helmet on and
Spacewalk officers here in Mission Control say they're go for the depressurization of the airlock. That should begin momentarily.
Discovery Houston on the big loop for EVA. We show the pre-breathe timer complete. You are go for depress.
Copy that, Houston. We'll get on the depress repress queues out. Okay. I'll stay in the area then.
This is Mission Control Houston with downlink television of spacewalker Steve Robinson as he continues to work with the airlock hatch in the shuttle's payload bay, reporting some difficulty in getting one of the latches or dogs closed, but that now has been completed at 5:41 a.m. He reported the orbital docking system hatch has been closed and latched. Station Shuttle complex moving into daylight over the western coast of South America in the area of Peru, an altitude of 220 statute miles. Now 58 minutes into this spacewalk.
Andy, we're now getting the WVS images. If you can hold that for a couple seconds, we'd appreciate it. We'll let you know when we're
WVS.
We've seen enough.
Blue Ficker.
Copy that. And it looks good. We're getting a really good image now.
Clearance plan.
Getting a view from Steve Robinson's helmet-mounted wireless camera.
Wait a little bit here. Discovery Houston, that's a great image. You're ready to go to press. We appreciate the views. Thanks. Okay. With that, Steve, you can, once Soichi's reconceived the APFR, you can install that in the bridge rail clamp. Okay. Okay, Steve, that's a Papa Foxtrot 12. It's feather to me still, so. Okay. I have it. All right. Okay, Andy, what's next for me? We do the NOAX first, right? We're going to do NOAX first. So we're going to do the timeline that was... Report, Steve. I'm covered. Okay, I'm yours. It's off you.
Here's a look at Soichi Noguchi from the vantage point of Steve Robinson's helmet-mounted camera.
That's worked great, don't they?
This is a long-range view of Steve Robinson and Soichi Noguchi in the aft end of Discovery's payload bay, making final preparations to begin work with the non-oxide adhesive experimental portion of this detailed test objective.
Sample areas and the frames, if you would. Okay, and we're... Interesting, it pulls, and it comes out. Okay, there's our first blob of NOAX. I'm sorry, I didn't... We saw it on the video, don't worry. Okay, Soichi. Okay. Try to force it in. crackling. Yeah, I just see a very little bit of bubbling. So we'll push it into the crack here, into the corner, make sure it adheres, since this is an adhesion layer. And try to scrape out most of what I put in. It's a little bit over applied. It's fairly gluey stuff, so it's a little hard to get off. I even try it that way since I want to remove material. Just wipe that guy. Lucy, you're doing it. Great job. All right.
This cock gun being worked by Robinson, very similar to the kinds of cock guns that
Good, healthy pull required. And tell us when you stop. Okay, forgot to tell you when I started. I'm still going.
very similar to the same kind of cock guns used by home handymen and handywomen.
Still coming out. And for the ground, that was 20 seconds. Thanks, Indy. Okay. That wasn't quite 3 by 3. I don't think I need that much. It's still coming out, Soichi. Okay. It continues to extrude about 1/8 of an inch or 1/4 of an inch per minute. I will work this a little bit. It's about like pizza dough. Like licorice flavored pizza dough. Okay, I would say that is working range 2. Copy that. And transfer it into the wet and starboard crack. Inward out and in to penetrate the crack and smooth the repair. Here we go. And Houston, do you want us to press on, or we could wrap this up now? It's your call. We'll check, Andy. Stand by. Discovery Houston for EVA. Andy, everyone is extremely happy with the way the DPO has gone. Your go-to, wrap it up, and we'll press with our next task. Okay, we'll do that. Nice job, Soichi. Thank you. You can stow the foam brush, I guess. Okay, Steve, can you get the foam brush for me?
One of the things they want to see in these tile repair tests is how well this material can be soaked into the tile substrate, in addition to its being able to help improve the heat rejection capability of the tiles. It's also intended to be a primer for larger tile repairs when the STA-54 ablative material is squirted into large damage areas like the one he's working on now. The idea is this thinner material can soak into the substrate, provide a better bond for the thicker STA-54 material.
Okay, squeeze again, 3, 2, 1, 1. 4, 5. Okay, coming good. Got it? That works pretty well. And as you may see on the WCS, the material comes off the foam.
The main objective of the tests were to characterize the material's behavior in the microgravity vacuum environment of space and to compare those results to the results that were seen in human thermal vacuum testing on the ground. The samples of the material that were used in the crack repair may be subjected to some entry-like conditions.
Opening. Some cables here.
Soichi Noguchi retrieving the primary cable that he'll be installing. And Robinson ready to remove the first of 3 bolts.
Bravo 4, counterclockwise 2, 30.5. Expect 9 turns. Clockwise 2.
That have been holding this active part of the external storage platform attachment device in place for launch.
Full day. Starting now. Okay, ID, I'm heading out to the station from here. And picking up the tether. Yeah, retrieve EV2's tether, peanut end only.
Meanwhile, Soichi Noguchi is in the process of getting ready to install a 20-foot-long primary cable that will connect power to the external storage platform attachment device.
Okay, it looks like it's a little high still.
And Steve Robinson now working to make sure that the compliant mount lock releases are released from the Enhanced Universal Truss Attachment System, or UTAS. Later on, he'll use a knuckle-like knob to completely release those. This is the locking mechanism he's releasing with the pistol grip tool now.
Okay. Andy, I think I would prefer to do that while this thing is attached to the structure. Now that it's here in front of me, rather than have it float off on a rack. I see it. Okay, we will hold that. You've removed it. You can now give a go for the arm operator to fly you up to the work site. Remember to flip it into the airlock mating position, and you've required forward station. Okay, stand by.
This is Mission Control Houston. Spacewalker Steve Robinson has removed all of the launch bolts from the external storage platform attachment device. He's holding it in his hands as he is suspended from the space station's robotic arm. Jim Kelly inside the space station's Destiny laboratory module will now begin to maneuver Robinson and the S-Pad, as it's known, up to the Quest airlock module for installation there. Again, this is the active half of the external storage platform attachment device, and it's going to be bolted to the outside of the Quest airlock module first so that it can grab a hold of the other side of the S-Pad, which will be connected to the external storage platform itself.
Discovery Houston, we copy Steve's report. We concur and we appreciate the words. You bet. Good motion. And we are go with the robotic motion. Starting to bring out, Steve, and obviously you'll have to control the S-Pad from the port itself. Copy. What are you doing? I'm ready to connect the first cable. All right. You have a go to do that, Soichi. And it's D602 to D602? That's correct. And Steve, just to let you know, we can fix this on the top end too, but we are going to have to take out the end effector roll that we put in before just to match the joint OCAS procedure, so you'll see us taking that out. Hey, thanks for the heads up, Biggett. Where am I? Heads down.
Steve Robinson getting a heads up from Jim Kelly inside Destiny Laboratory while he's heads down that he's on the move on the way up to the Quest airlock module with the external storage platform attachment device.
Assembly now. 519. motion, Vega.
Copy, Stephen. We'll be looking for any stop calls from you, and we'll expect to hear all stop 3 times if you see anything you don't like.
Copy that. Gonna do the flip here. There just are no words to describe how cool this is. I see 1 meter to go.
This is Mission Control Houston. You can see Canadarm2 with Steve Robinson on the end, moving into position to install the external storage platform attachment device. Just above and to the right of him is Soichi Noguchi upside down there in the assist position.
Plan is we'll just touch it over the trunnions, and then we'll get the arm to position hold. And maybe I should have tapped on it or something. I think it just flopped in. Okay, Houston, did you copy? We've got both the pins in, plunges in. How do you like them apples?
Houston copies, and we like those apples. Good job.
Okay, Steve, you can open the port V-guide latch. Is that one of those? I see to do this. Okay, Steve, you want low profile, 6 X-ray, X-ray, Lima 2. 6 X-ray, X-ray, Lima 2. Steve, I'm going right behind you now. Oh, okay. Sorry. Okay. Guess I'm clear now. All right. You're clear? Okay. Let's see, I got that right. Oh, I know. Let's do it correctly. No, can't quite get it in there. Okay, I vote you leave it at Lima 3 then. Lima 3, okay. And we can see what you mean. It's the flange that looks like it's striking the structure.
This is a view from Steve Robinson's helmet-held camera as he is adjusting some handrail gap spanners that will help provide locations for the crew members to maintain their tether protocols. He's now at a patch panel that he's going to be swapping a couple of cables to make it possible for power to flow back into one of the control moment gyroscopes that has been down since it was failed because of a fuse or a circuit breaker.
P2 from J2.
The control moment gyroscope is fully functional. It just isn't able to receive power through that fuse or circuit breaker. This patch panel reconfigure that Robinson is going to continue with here is going to hopefully restore power to that control moment gyroscope. We're back with live video from Soichi Noguchi's helmet camera, looking at him install the new replacement global positioning system antenna.
Stop. Copy that, Soichi. And I can give you PGT settings to install those bolts when you're ready. I'll stand by.
Noguchi reports he has a good soft dock of the antenna. He'll now install and drive 3 different bolts that will hold it securely in place, and then reinstall the insulation around it. Receiving some downlink television of Canadarm, the shuttle's arm as it is moving with its orbiter boom sensor system extension.
Okay.
Jim Kelly and Charlie Camarda at the controls for this robotic arm, moving the OBSS back into a position where it can take some intensified television camera images of the leading edge of the port wing of Discovery. Several different areas of interest having been identified by the imagery specialists and engineers on the ground from previous imagery that was downlinked from aboard Discovery. Again, these specialized inspections intended to help verify the condition of Discovery's thermal protection system to make sure that they're in good shape for re-entry when Discovery returns home to Earth. This is Mission Control Houston. There's a good view of Steve Robinson, spacewalker on the outside of the Quest airlock module. This view coming to us from Space Station camera. On the very left of your screen is the end effector of Canadarm2. And below is the Baja Peninsula. Shuttle station complex orbiting 220 statute miles over the North American continent. This pass will take it over Southern California, New Mexico, Arizona, Colorado, Nebraska, Wisconsin, and Minnesota.
And then, if you would, we'll close the lid of the DTO box, remove the 2 pit pins from the hinge, stow in the lid, and then close the lid. Copy. And stow them in the lid. Pump pins out. Discovery Houston for EVA photography. Go ahead, Mike. Andy, we appreciate all those photos of the DTO material without the flash. However, the folks would also like to get, at least at some point before we ingress, at least one shot flash of an object of something about 10 feet away. This is the only opportunity they have to test the flash. We'd like to get at least one. I'd like to get at least one shot, and he can continue with what he's doing once he closes the box. Anytime afterwards, we're okay with a shot with the flash. Vegas from EV2. Go ahead, EV2. I'm just looking right at you. Discovery Houston for EVA. Go ahead for EVA. Andy, as it turns out, we're good with the one shot with the flash that he took at the beginning. We're good with the flash. The only other pictures we like is once he's done at the box before ingress, if he can get those shots of the billowing near the window. So Richie, head on home. Head on home.
This is a view of Steve Robinson from Soichi Noguchi's helmet camera. Robinson taking a picture of Soichi Noguchi as he's headed back into the payload bay of Discovery.
And Soichi, you stow the camera on the fuse tether. All right. So we're okay to roll to my left like this? That's the better way. Okay.
You did a great job today. It's just been a pleasure for us down here to work with you. Awesome views, great job. Everything was just perfect. Extra stuff got done. It's just been wonderful working with you today. A real treat for everybody down here. We look forward to another 2 great EVAs and a great flight continuing. We're going to hand you over to the shuttle room, and you'll be talking to Julie.
Okay, Mike, thanks for your support. We appreciate it very much, and the efforts of Cindy, Matt, Allison, and Zeb, and Rolf to make all this happen. Next pass, young EVA2. So long, Mass, and City Matt Nelson and Zip, and Rolf.
Well, everyone's smiling. We appreciate all the nice words you have for us throughout the EVA. The whole team appreciates that as well. You guys get some rest, get inside safe, get some rest, and we'll talk to you soon.
You bet. See you, Matt. Okay, I'll be standing by if you got any words for any additional things that need to be done.
Well, the only words we have, I'm not sure if Soichi and Steve are listening, but clearly this was a flawless EVA today, and we're happy to report that both Soichi and Steve, just like you, Andy, have now been officially welcomed to the EVA Hall of Fame because Cindy said so right on NASA TV about an hour ago during the mission briefing press conference. So you might want to pass that along. And by the way, Andy, impeccable IV work. Well done, guys.
Well, congratulations to Steve and Soichi for making the Hall of Fame. You've got a big beaming smile out of Steve.
I'm sure that makes him happy. I guess the next step is to become part of the Rock and Roll Hall of Fame.
That's the bigger challenge.
Oh, not for you, man.
Good day and welcome back to the Johnson Space Center for today's mission status briefing following the first spacewalk of STS-114. With us today to discuss all of the day's activities, Phil Engeloff, the STS-114 Mission Operations Representative, Mark Faring, the STS-114 Lead Space Station Flight Director, and Cindy Begley, the Lead Spacewalk Officer for this mission. A reminder that Phil will be having to leave in a few minutes to attend the Mission Management Team meeting today, so we're a little bit short on time. And we'll start off with Phil.
Okay, very good. Thanks, Rob. For Flight Day 5 today, again, the mission is continuing extremely well from the operations standpoint. The flight control team and the crew got through the list of activities today with a great deal of success. We managed to execute all of the planned tasks in the EVA. We did accomplish the planned DTO activities at the start of the EVA, and managed to rewire to recover CMG2, and I think Mark will probably give you some details on the progress of getting that CMG back up and in the set on the space station, and completed the wiring that we had planned to do in anticipation of the coming two EVAs for the external stowage platform and for the CMG remove and replace on EVA 2. And in fact, we were doing so well, we managed to pick up a couple of extra activities. We retrieved an experiment from the space station called Missy, which was planned to be retrieved on EVA 3. We got a little get ahead there. And for the shuttle program, we got the crew to take a couple of external photos of the blanket just below the commander's window 1, which I think you've seen some pictures of. That was sort of a target of opportunity that we realized yesterday we might get, and we added that sort of late, and the crew picked those up for us towards the end of the EVA. As I left to come over here, we were in the process of continuing the focused inspections to pick up those targets that we had not accomplished on the previous day. And we picked up the few that we hadn't done on that day and some additional ones that the engineering community had requested of us. So we got a couple of spots on the RCC and a couple of places on some of the T-seals a little further down the wing. And I wasn't able to stay for the completion of that, but it looked like that was going well, and we should get most or all of those inspections done this time. That's a pretty successful day, realizing that this is a first-time EVA crew, and things are always a little bit slow for folks making their way through those procedures the first time. We were a little late getting out the hatch this morning, but during the EVA, they finished the timeline within the appointed time, and as I say, picked up a couple of extra activities as well. For tomorrow, it's a fairly simple day in terms of the complexity. It's mostly just MPLM transfers and some prep work for EVA 2. From the ground standpoint, it's a relatively quiet day, although the crew will be kept very busy doing the transfers, but not a complicated day. That's pretty much all I have. Again, everything is going great on the mission as far as the execution is concerned, and we are on target to complete all the planned tasks. Mark?
Thanks, Phil. I'm extremely happy to be here with you today. I got to do all the fun stuff on the EVA this morning, and then I got to leave and let one of my buddies kind of handle all the cleanup items, so thanks for asking me over. I'm not going to say a whole lot here. I'm going to turn it over to Cindy to give you a lot of the details of what happened, since her and her team are the experts for the EVA. But I want to echo Phil's comments. You know, Steve and Suichi are EVA operators today. It's their first EVA, and they've been training for this for a long time, and you can tell both with the training that Cindy and her folks have provided and the hard work that they put into this. They did an extremely good job. They were moving as if they've been outside all their life, extremely comfortable and very efficient with the jobs that they did, and I couldn't be more pleased with that. In terms of the interaction of all of the teams, the Space Station Flight Control team working with the EVA crew members just went fantastic. I think, as you know, we have the space station operators who fly the space station, and they're up there all the time, and they don't really get to train with the space shuttle guys. And John Phillips this morning, along with Sergei Krikalev, were coordinating operations with our shuttle team, operating the RMS to set it up, the station robot arm to set it up for the EVA activities today when the hatches were closed. And since they didn't get to do any training with that, we're always a little concerned that might get a little bit behind as well. And again, that did not happen. They did a professional job, and again, very efficiently. And we not only said in the timeline, we did well enough that we could get ahead and do some extra tests, as Phil mentioned. I wanted to mention a couple things that we were very excited about on the space station side. As Phil mentioned, we did get back one of our CMGs. I think you know we're down to only two. The four, and I think you also know that the gyroscopes that we have in the space station allow us to orient the space station without using any propellant, zero propellant at all. And if we got down to only one, we'd have to use the thrusters on the Russian segment in order to control our attitude. So we really did not want to get down to a single gyroscope. And with the recovery of the gyroscope here today, we're back up to three. And after EVA2, when we're going to replace an entire hardware gyroscope, we should be back to the full complement of four. Today, what they did is the gyroscope itself was fine, but they had to swap some connectors because they had a power box that had a problem. So we just routed power from another source. And as at the time that I had left, the electronics assembly had been powered up. They'd gone through a full checkout of the electronics, and they're spinning up the 100-pound rotor that's used at the top that's inside of the gimbal, so the gyroscope. And it takes about 8 hours to get that thing spun up. And then after make sure that looks good, we'll put it back into the steering wheel as one of the three in the sets, and then we can use it then for normal operations. So that's looking very good. The GPS antenna, kind of like the ones you use in cars now all the time for your nav systems. We added our fourth into the complement. We have four generally, and one of those had failed. You only need one in order to get state information, where you are with regard to the planet, altitude, and velocity. But if you want to get orientation, pointing information, harkening back to your days of trigonometry in high school, you need at least three to triangulate. So we want to make sure we always have at least three. So we have a source of orientation from the U.S. side. And that has already been checked out. It's working perfectly, and it's being used normally at this time. So we're very excited there. We also routed some cables in preparation for the stowage platform that we're going to install on EVA3, so that kind of was a get-ahead for us, and we installed, part of that package was the SPAD, the ESP2 attachment device that we installed on the airlock trunnions, and Cindy will give you more details about that, but that also went well, and it's in place, and we're ready to go. So EVA1 is complete, and we're ready for the next two, and again, a very exciting day for us. Cindy?
Well, good afternoon. I think it's afternoon. I'm about to go to sleep myself. I can't even begin to tell you how excited and happy I am to welcome Steve and Suichi into the EVA Hall of Fame. They have a total EVA time of 6 hours and 50 minutes today. They completed all of their scheduled tasks, and they did all of them on the timeline, and even some of them ahead of the timeline. And as we've said already, we did add some extra tasks. We went ahead and retrieved the MISSI 1 and 2 science experiments and brought those inside. That was planned for EVA3, so we've gotten ahead on that. We added some extra photos, and I'm just more than happy with the performance today. I understand that we have some video clips to show you for some of the planned tests that we did today, so I'd like to roll those. And this is on the DTO on the tiled board. And you can see the left upper corner is the PGT sample. That is where Soichi's going to work on the EWA, and you can see Steve on the right extruding the NOAX. And there he is working with the NOAX on the pallet, getting into the right working range before he applies it to the top of the sample. He was able to complete that first row of the porosity sample, that's what we call that sample, and we also did the second row. Most of that was kind of dark for us to see. And here you can see Soichi is applying the emittance wash. Here he's using a brush transfer technique for areas that are a little bit too tight for the whole tool to fit. And he just has to extrude the material on the tip of the brush and pass it in. In this clip you can see Steve is releasing the first launch bolt for the S-pad, the ESP2 attachment device. Had some problems with that, went up to a higher torque and got it released. You can see he's got it in his hand now. And this is the SSRMS transfer with the S-pad and installing the S-pad. And we had several tries at installing the S-pad today into the soft dock. A little bit of thermal issue, and Soichi came down and helped out, and it all worked. And this is a clip of the very beginning of Steve doing the patch panel reconfiguration for CMG2. All he's doing there is removing a dust cap and taking a cable and plugging it in, the cable that provides power to CMG2, and plugging it into another power source. Other items that were done today, the GPS antenna we already discussed, had a little bit of trouble getting it out at first, but got all the wire ties removed and everything went just fine. The last test they did, they actually had to remove the CETA cart. This is a EVA translation device on the same rails that the SSRMS rides up and down on. We moved that out of the way, got the connectors in, and routed that cable. At the end of the EVA, Soichi went back and closed the lid of the DTO box and was able to take a lot of photos with a digital camera. This is a brand new camera for EVA. It includes a flash system. He was taking those photos in a method that we're going to use to analyze on the ground and look at depth measurements using photogrammetry techniques. After that was closed, we went ahead and went up to the forward side of the lab and pointed that camera down at the port forward window where we have some MLI blankets that we're billowing out a little bit to get some extra photos for the shuttle team. And again, at the end there, while Steve still had some time, we went ahead and got the other Missy inside. So I'm more than happy with how everything went today, and I'm ready for any questions.
Okay, we'll take questions here in Houston. Before going down to the Kennedy Space Center, please state your name and affiliation.
Hi, it's Craig Cavall with Aviation Week for Cindy. Please take a minute, and even more so there, because I would like some detail on the character of the defects machined into the RCC sample. For example, what makes a porosity sample porosity? Difference between the top row and the bottom row.
And actually, the top row of the porosity sample is identical to the bottom row. And what we're looking for in the porosity sample is the difference in the distribution of the bubbles and the way the material cures on orbit versus when we're doing it in a thermal vacuum chamber on the ground. We had two cracks in that row. One of them is a little bit wider than the other. Both of them are through cracks. They go all the way through that RCC panel. And then there was a gouge in the middle that just had coating loss on part of it, and then a little bit deeper into the substrate. So there were different techniques that we used for repairing those different types of samples. Now we wanted to get as much data as possible and go ahead and get both rows of that done today. And our minimum criteria that we thought we were hoping to get done today was just the first row. So we got both rows done, and we were very happy.
Bill Harwood with CBS, two for me and one for Cindy. On the ArcJet panel, I guess they didn't get done, or that sample one. Why didn't they do that, I guess, and what do you lose by not doing that? And for Mark Fearing, I think, can you tell me what's going on with CMG3 and your strategy? I guess you can take that out of the set while you're docked and then put it back, and just tell me about that.
Okay. The ArcJet sample is an impact sample. It has a T-shaped damage with a bit of a dent. and it could have been put in the ArcJet after the flight. It was actually our third priority. Based on our pre-flight NVL runs, we did not expect that we would get that one done today, but we always plan for a little bit more than we can do just in case we had time. At that point in time, our estimate on consumables was such that we needed to go ahead and move on to get all of our tasks done. STS-114, I'm not really up on it, but they do have more than one ArcJet sample in their DTO box ready to do. So we've done the important first step to get ready for those DTOs.
Okay, Bill. Of course, I know you're very well versed in the station and a lot of things that are happening with us. And the CMG-3 has been one of the CMGs we've had some concern with for a while. And the difficult thing for us, of course, is we can't bring it back to the Cape and go look at it. So we have to theorize about what problems we're having based upon the limited data set we have on orbits. And the theory with this particular CMG is it has a self-lubing capability on the bearings, and there's concern that perhaps it's not lubricating itself, not adding lubricants over time. I can't tell you that that's the real problem, but that's one of the theories. And so we've seen over time a slow increase in the amount of currents that it takes to rotate the rotor. And occasionally you get, that's called the spin motor currents, and then also occasionally the vibration will go up in the system and measures vibration at micro G's at a very, very low level. And this is one of the reasons why we've, when you get an external type of disturbance, you will see these kind of artifacts in the performance of the CMG at a much lower external disturbance level than the other CMGs. And so that's one of the reasons why we docked using Russian thrusters in this time, because we're trying to protect that particular CMG. And we started to notice yesterday, even when moving the SSRMS unloaded, that we're actually getting higher signatures on this device than we'd seen before. It would happen for a momentary period, and then it would go away. And last night, even when the crew was asleep, we saw some other signatures when we weren't even providing any external type of disturbances. And to be prudent at that point, not understanding what's going on. And since I'm executing today for the EVA, I haven't really had a conversation as to what the engineering world went through overnight to make the decision. But I think it was basically prudent. We don't need it at this time. We'll take it out of the steering law, so it can't have any of these effects of the disturbances at all. And since we're going to pick up these other two CMGs, there was no particular reason to stretch the CMG if we didn't need to. And then we'll talk about it further and see if we can figure out where to go from there. But like I said, since I haven't been part of the engineering discussions, I'm not sure what the process of elimination is going to be and how we get to the point where we make our decision what we're going to do with CMG-3.
Marcia Dunn, Associated Press, with two repair technique questions. Have any of you heard from any of the people who actually developed the materials and gotten any input on what they thought about how this stuff behaved in space?
And I've actually heard from the DTO team. They're all very happy with what they saw today. Mike Effinger is the lead for this material, and he was here in the back room listening to the loops. So this was pretty much as expected for the temperature that we saw the material at. So we saw it from about 33 degrees Fahrenheit at the end and about 57 degrees at the beginning. The material was on the colder side, but still quite workable. We saw some bubbles, but not the kind of bubbling that we see at higher temperatures. And the material was very, he was saying it was a working range 2 for quite a long time compared to what we were expecting. And that's, when we say working range 2, that's the workable range. Working range 3 is when you need to stop because it's starting to tear and roll away. So everything looks great on video, and we can't wait to get it home and take a look at it. They will be doing evaluation of that sample where they can see the whole distribution inside the material of voids, et cetera, and how well the material hardens. We'll be able to see how far the material actually went into the cracks in the sample. So they're pretty excited, ready to see.
Refresh my memory. This was real thermal shuttle towels in RCC, and did you remove them from one of the shuttles, or were these just spares?
These were built specifically for the DTO box. All of these were built specifically for the sample box.
The real material is what would fly on the shuttle, identical?
Absolutely identical material.
Jim? Okay, Jim. Yeah. Okay. Jim Oberg with NBC, and Mark, good to see you here too. It's more fun here. We've been watching you getting ahead on EVA-3 tasks by doing things on EVA-1, and Wayne Hale last night mentioned that the consideration was being given to an extra task on EVA-3 that might involve pulling back a motor on the radiator rotation motor because of funnies on that. What would you explain to us, both of you please, in terms of EVA, how are you gathering potential add-on tasks for EVA-3 to help in the case of a long time to next shuttle flight? How are you getting these suggestions? How are you getting them approved? How are you going to implement them and train for them? And might it make sense to put the extra day, the extra flight day, which you may get today, before EVA-3 so you have more training time? Anybody wants to comment on that?
Let me take the first part of that on the process of how we're going through that. The MMT asked the station program a couple of days ago to work on that, and essentially we pulled together teams representing both mission operations and program interests from both the shuttle and station programs to look at what capabilities we have, either in terms of EVA tasks or any of the other logistics transfers and so forth, to pull together basically shopping lists of proposed tasks that would help the program. Those teams have been working over the last 24 or 48 hours or so, and Robert Galvez of the Space Shuttle Program Office has been tasked with integrating all of those inputs together into a recommendation to the MMT. He has pulled together a preliminary list of recommendations, but I can't tell you what they are. I haven't seen them. We'll see them at the MMT here coming up in a half hour or so. But basically, it'll be weighing the costs of doing those tasks in terms of operational costs or margin to the shuttle or the benefits to the station, and just weighing what can be accomplished within the timeline, putting a recommendation together for what content we'll have. We will be making the recommendation to the program to go ahead and add the day to the mission. We're very close on the consumables. We're right at about 23, 24 hours now on O2 margin, and Mr. Hale indicated yesterday in the MMT that it was his inclination to go ahead and add that day once we showed that we had the consumables in hand. So I think those two things will converge, and we'll add that day, and we'll have probably a pretty good plan for the content tomorrow or maybe the next day.
EVA-3 in terms of, are there specific things in EVA-3 that the EVA people are starting to get some look ahead?
There are, I think, several options, and Cindy, I don't know if you guys have been included yet since you were engaged in getting ready to execute this first EVA. There have been a couple of optional tasks put on the table. I can't tell you the maturity of the proposal for those. We're looking at them and trying to see how they will fit in. If we make time, we may do that. I wouldn't promise until the team's had a chance to look at it.
Okay.
I'm Guy Gugliotta of the Washington Post. A couple of questions for Cindy. Steve and Soichi trained for quite a long time to do this. Even though it was their first spacewalk, how would you categorize their ability to, did they do it like they could do it in their sleep? Take a lot more work to sort of get comfortable.
Absolutely, they did it like they could do it in their sleep. It was really amazing. They, every first-time EV crew has a little bit of a learning curve to get over when they've got a lot of training behind them in the NBL. That things are a little bit different in space, and these guys just did great. Everything went right on schedule, so they're real happy.
Just a second question. Steve, while he was working with the NOACs, remarked several times that even though the NOACs was not bubbling, it was swelling up, and he sort of indicated that was kind of unexpected. Was that unexpected, and what does it mean potentially?
No, that's not entirely unexpected. We did see this behavior in the human thermal vac and in the glove box training that we do, not training, but testing that we do. All of the training was done just at 1G, at ambient pressure here. So that's fully expected. Several times we saw after the sample was complete that the material would extrude a little bit out of the crack again, and you might have to put more material on and smooth that out. But as long as it's not real high, we're doing great.
Hi, Tom Costello from NBC News. Two questions, one for Cindy. You talked about the learning curve. Can you tell us what is the biggest thing you got to get used to when you step out onto your first EVA? Is it the gloves being so cumbersome? If you can talk about what is the biggest shock to the system when you step out at an EVA that the astronauts have to get used to? And then for Mark, can you address, we understand that the next shuttle mission to the ISS, nobody knows exactly when that mission might be. What kind of supplies do they have on the ISS? In other words, how long can they last before a next resupply mission, either from Soyuz or from the shuttle?
Okay. I think the biggest shock to the system is coming out of that hatch for the first time. A lot of people experience vertigo. You come out and you see the Earth spinning and you feel like you're falling. I've had crews in the past tell me that handrail right above the hatch is dented from people hanging onto it so hard. The other thing is when we do our training in the water tank, there is still gravity. Everything likes to fall down. We try to weigh things out so they're floating a little bit. But if you put something down on top of structure, it just lays there. And as you can see when we're doing an EVA, you can get kind of a kilt bed moving around on you and having to keep track of all of that. Everything kind of needs to tie down. By the same token, though, you can kind of move something out of your way and just bat it around. It's really easy.
Okay, and Tom, to attempt to answer your question, as you might imagine, there's a small army of people that their job is to keep track of the consumables and all the things on the space station that we have that work and don't work, and the things that you use up like air and water and food and fuel and those kind of things. And we have hardware like the CMGs and the GPS antennas that we just replaced and all that and that kind of thing. And I think we've demonstrated pretty well over the last 2.5 years that the consumable items we can keep up with if we have to, if we only have 2 people on board with food and air and that kind of thing with the Russian supply system and working with our partners. I think the bigger risk, if you go really long periods of time, is some of the hardware items that are so large you can't fly them easily in a progress, that kind of thing. And that's more based upon luck of the draw and what things have failed. And I think when we replace our CMGs here and get them going and the GPS antenna, I can't, and I'm not part of that small army that can give you all the charts and graphs as to what we are at right now, but I'm confident that we can go for quite a long time with the situation we're going to be in at this point.
All right, we'll take Frank and Mark, and then we'll go down to the Kennedy Space Center for a question. Go ahead, Frank.
Frank Moring with Aviation Week for Mark. In addition to the EVAs, I think there was a lot of work going on inside the stack today. Can you describe the strategy for getting everything out of the MPLM and out of the station and into the MPLM and vice versa, and how that work's going?
Sure, and I was actually going to try to get a status for that today, but they have a call down every evening about what they've done in terms of transfer, the exact items that have gone across and that kind of thing. I did not get that today for you, so I'm sorry, but I can tell you in general. On this particular mission, because as you might imagine, it's been so long since we've had a shuttle, there's a lot of materials on the space station. Instead of, a lot of times what we do on an MPLM flight, when the MPLM gets mated, the first thing we do is empty it. We take everything out of it and we stage it in the space station, and then we start packing things back in. In this case, what we've done is we created what they call, what Wendy Lawrence, who's our loadmaster, called the bungee jail at the end cone of the MPLM. It's quite a large area, and actually everything that we're going to put into the MPLM to return, my guess is pretty much all of that is in there today. They move all of that kind of the fireman's thing where you start shoving down bags and items that you're going to strap in and put in the drawers inside the MPLM, and they put it all behind these bungees. in the MPLM, and then they will start removing items then from the racks and the panels in the MPLM and start putting that basically from the same place where we just took all that stuff that we put in the bungee jail in the MPLM. And then at that point on, they have a big list and they start taking the items from the jail and putting it in its place, and it's kind of just like working in your closets in your garage, and it's a lot of work, but Wendy's going to be a real taskmaster to make sure it gets done.
I'm Mark Karofny, Houston Chronicle. I have two questions. The first is for Cindy Begley. I want to make sure I heard right. None of the samples of RCC will be arc-jetted when they're back on the ground. And can you say what happens with the EWA samples that you worked on today, or sample?
Okay, no, you are correct. None of those samples will be arc-jetted. These will be, we call it non-destructive evaluation. I don't know, I'm not an expert, so I don't know what the machine they use to look at that, but they can look at the porosity distribution within the material after the fact. And once they've done that non-destructive as much as they can actually section the material and look at it, a side view of all the material that was on there. And as far as the emittance wash, what we'll be looking at, this was primarily an on-orbit test, and what they're going to be looking at on the ground is just the amount of coverage we got versus the amount of material we used, so that can help us with our estimates of how much material is needed to get a good coverage. So what we were primarily looking for there was any surprises on how this material behaves as we're applying the material to the tile surface.
Follow-up.
Do you, from what you saw today, do you have any sort of opinion on how easy it would be to work with these materials now that you've seen them used in a vacuum in a weightless environment? If they met spec to actually do a repair, do these seem like substances that could actually be used during a spacewalk and done rather quickly?
And for both materials, I felt like operationally applying this material was very easy to do. We were actually prepared and concerned and expecting for things to get to be a little bit of a mess. You just don't know, and that's why we do this testing. But it was very clean. They had just minimal amounts of material that they actually got on the back of a glove and on the side of a glove that they wiped off and were good with. But there wasn't a big issue with containing loose material or any excessive extrusion from either of the tools that we had to worry about.
Okay, let's go down to the Kennedy Space Center for a question, and we'll come back here for a couple of follow-ups.
Dan Billow from WESH TV for Phil. How far do you really think you got with repair techniques here, given such a narrow range of damage that you had there? I was even wondering if you had that sort of damage represented by the DTO sample in the real world, would it even need to be repaired?
It's a little bit difficult to answer that. As you've been aware over the last couple of years, we've gone through quite a wide range of repair capabilities. Among those that have shown the most promise, of course, were this NOAX material that we were testing today and the emittance wash capabilities. I think our expectation is we are fully prepared to do an emittance wash kind of repair if it were required. As far as the RCC, it's a little bit more complicated. We have been able to do quite a bit of testing of the kinds of mechanical materials that we would use in the ground environment, and so the fact that we were testing a relatively limited scope of things today is more an indication of what it's worthwhile to have to test on orbit. And there was even some debate about how much additional knowledge was being gained by doing these tests in zero-G, true vacuum, accurate thermal conditions, and so forth. The NOAX is specifically targeted for these types of small repairs and not certainly for the large kinds of damage that have been discussed since the Columbia accident. So I think that this test was appropriate for the material that we were we're applying it to today. And yes, even for these small damage sizes, there's a fair amount of analytical and testing evidence that crack sizes on the order of what you've seen in these damaged samples are in fact a concern. And had we seen anything of that magnitude, we would seriously have addressed the possibility of making these kinds of repairs for the flight.
Irene?
Thank you. Irene Klotz with Reuters. I have two quick questions for Phil and one for Cindy. For Phil, will the Missy cases be coming back with the 114 crew? And also, could you talk a little bit about the need for the RCC inspections on the left wing that the other crew members were doing during the spacewalk, if those were simply missed in the first sensor sweeps the day after launch, or did you see something that you want another look at? And for Cindy, if you could just talk a little bit about the strict thermal criteria you had for doing the TPS test today, and if that's actually a realistic criteria for doing heat shield repairs, if you have to be in the sun and 15 minutes of heating and so forth.
Okay, let me take a quick shot at the first couple of pieces of that question. As far as the Missy experiment, Mark informs me that yes, that comes back in the MPLM. So they'll come back on this flight. They're being replaced with the Missy 5 experiment that gets installed on EVA 3. I'm sorry, remind me of the second part of your question again.
RCC inspections today?
I'm sorry, yes. One of the great things about this flight is we're collecting a lot of information, and when we did the scans on day 2, we've processed that data, and we've seen in that data areas that we'd like to go take another look at. And I want to stress emphatically that these are not areas that are giving us great concern for the health of the vehicle, but when we do see something that doesn't look like the background material, this is an opportunity for us to go take a closer look. The more data we have looked at over the last couple of days, and the more time we've had to analyze that data, we've continued to develop a shopping list of additional targets that we'd like to look at. Each time we look at one, we learn something that tells us about what else we might or might not need to look at or want to look at. Depending on how the results of these inspections come out today, we may or may not choose to look at additional targets. I think these are useful for a couple of different reasons, both for giving comfort to the RCC community that the RCC is in as good a condition as we think it is, and I would put that in the category of confirmation. And then I think there's some value here in what we can learn about what we can or cannot see with the instrumentation. And once we've compiled those things together, I think we'll be better prepared either on subsequent days on this mission or on subsequent flights to adjust our criteria of what things we think we need to go look at. Cindy?
Okay, and I guess you asked about the thermal criteria. For the NOx material, the ideal working range is between 40 and 100 degrees Fahrenheit. And again, we ran from, we started out at about 57 and we went down to 33. And we did see the characteristics that we've seen at colder temperatures where at the end of his test, he was starting to see the material rolling and not sticking as well. The emittance wash material does not have the same thermal restriction. It can be applied at a much wider temperature range. And I'll go back to the, how well I feel about doing a repair. Again, applying the material seems to be an easy thing to do. The big trick is getting the access to the location that you're looking for, and of course, getting the thermal range that you're looking for when we're there. But we did prove today that we can sort of time our things, get our tools and access ready, and hit the thermal window that we're looking for. We did notice that our temperature predicts were a little bit high compared to what we ended up with, and that's something that we can learn from and take with us today.
Take one more question, wrapping up. Max with Radio Canada, question probably for Bill. I just want to understand in simple words, what is the idea behind having one more leave the mission? What do you want to accomplish? And can we take for granted that it will happen?
On the last part, I think after the MMT today, you'll have a firm answer that it's going to happen, and I would give very high odds that that's going to be the case based on conversations with Wayne Hale and knowing the status of the vehicle and our ability to provide that. the fundamental idea behind adding the day is to give this crew additional time to help put the space station in the best possible configuration that we can with the tools that we have on board, to protect against the eventuality of delaying 121, STS-121, or quite frankly, just to be able to do as much as we can with the on-orbit time that we have available. Every mission, we try very hard to maximize the content of the mission while still maintaining reasonable margins for unexpected possibilities. Every mission, we generally have a list of things that we would like to do if we had more time, and when we put ourselves in a good posture on orbit with the resources that we have, extra consumables, it makes good sense for us to take advantage of that. If you stop and think that we fly, when we're in our stride, 4 or 5 flights a year to the space station, and we get 6 or 7 dock days each flight, you're talking about 30 days or so on orbit that we get to maintain that space station. And if we can add 1 more day on each flight, we're making a 15 or 20% increase in the available on-orbit time. We're just trying to maximize the productivity of the flight.
Could you give me one or two very simple examples of what you would do in that day?
The kinds of things are either doing additional transfers that we didn't plan to have time for, finding consumables or tools or resources on the shuttle that we might be able to leave with the station, or using the crew with the additional shuttle crew members to help the station crew do more maintenance activities that would take time away when the shuttle's not docked. That category of things.
Okay, thanks. We'll close with a couple of programming notes. Coming up at the top of the hour at 1 p.m. Central Time, we'll play the solid rocket booster video that was captured during Discovery's launch back on Tuesday. At 4 p.m., we're going to replay the video file on the new planet Discovery that was announced late yesterday. And at 5 p.m., right back here, the post-mission management team briefing with Wayne Hale, the Deputy Space Shuttle Program Manager, and Bill Gerstenmaier, the International Space Station Program Manager. So we'll see you back then. Thanks very much.
Die Discovery-Astronauten Noguchi und Robinson. Heute starteten die beiden zu ihrem ersten Weltraumspaziergang aus der Raumstation ISS auf das Shuttle. Beim spektakulären Spacewalk war diesmal vor allem handwerkliches Können gefragt. Mit Spachtel und Tube rückten die Astronauten der beschädigten Außenhaut zu Leibe. Getestet wird, ob ein neuer Klebstoff die Schäden vom Start beheben kann. Die Discovery soll für die Reparaturarbeiten einen Tag länger als geplant an der ISS angedockt bleiben und dementsprechend später zur Erde zurückkehren.
Was der Discovery-Astronauten heute taten, klingt zwar harmlos, ist aber ziemlich spektakulär. Sie unternahmen einen Weltraumspaziergang, aber nicht um sich die Erde aus gut 360 Kilometer Entfernung zu betrachten, sondern um ihre Raumfähre auf etwaige Schäden abzusuchen. Beim Start war ja ein Stück der Tankisolierung abgebrochen und womöglich auf einen der Flügel geprallt. Auf Fotos und Videos war zwar nichts zu sehen, aber die Astronauten sollen das mit ihren eigenen Augen überprüfen.
Die Weckmusik ins All kam heute von einem japanischen Kinderchor, denn den japanischen Astronauten Soichi Noguchi erwartet ein ganz besonderer Tag, sein erster Weltraumspaziergang. Wenn du richtig hingehört hast, Soichi, hast du vielleicht im Chor die Stimmen deiner eigenen Kinder vernommen. Ich danke meiner Familie für die großartige Unterstützung, antwortet Noguchi, und jetzt raus ins All. Einer der spannendsten Momente dieser Mission. Noguchi und sein Kollege Stephen Robinson verlassen die Raumstation, schweben gut gesichert im Weltall. Sie sollen feststellen, ob die Discovery Beschädigungen hat, die einen Rückflug unmöglich machen, einzelne kritische Stellen genau in Augenschein nehmen. Sie testen auch neue Reparaturmethoden für die empfindliche Außenhaut des Space Shuttles. Das Team arbeitet sehr hart. Sie müssen sich vor allem die Unterseite der Raumfähre genau anschauen. Wir führen alles so durch wie geplant und gehen davon aus, dass wir der Discovery am späten Samstag oder am Sonntag ein gutes Gesundheitszeugnis ausstellen können. Jetzt werden die auf dem Allspaziergang gewonnenen Daten genau ausgewertet. Dann erst steht fest, wie es um die Gesundheit der betagten Discovery tatsächlich bestellt ist. Die Astronauten sind vor einer halben Stunde wohlbehalten in die ISS zurückgekehrt. In diesen Minuten will sich die NASA zu ersten Ergebnissen des Weltraumspaziergangs äußern.
Nach einer ersten Stellungnahme der NASA gibt es bisher keinerlei Anzeichen dafür, dass eine Rückkehr des Shuttles zur Erde gefährdet sein könne.
What's an update on their first spacewalk next on CNN? Two astronauts floated out of Space Shuttle Discovery for their mission's first spacewalk on Saturday. After an hour spent getting their space legs, they began testing damage repair techniques for the shuttle. John Zarella spoke to us just a short while ago from Johnson Space Center in Texas.
That's right. The first of 3 planned space shuttle spacewalks has been wrapped up, just finishing that up now. The astronauts put away the tools and cleaned up the cargo bay in the shuttle. And this, again, the 6.5 hours in all that they had been spacewalking, and now preparing to go back into the hatch, close the hatch and be done for the day and get some much needed rest. Of course, you know, the one thing we always love are those spectacular views from space, and they did not disappoint again today. The image, the picture here we see is of astronaut Steve Robinson as he is going hand over hand down the space station handrail with the Earth below him falling away. Just one of those spectacular shots. Again, many, many great images of the 2 astronauts working in the cargo bay today. And what they finished up late in the spacewalk, repaired an antenna, replaced a communications antenna on the side of the space station. But the big events took place at the very outset of the 6.5 hours. They were testing the techniques that could be used in the future should astronauts need to repair tiles in space. And of course, it came as a recommendation out of the Columbia accident that NASA come up with ways, techniques, and materials that could be used in space by astronauts in the event that tiles are damaged in space. And what they did at first was to get out the old, pretty much a home repair caulk gun, modified for space use, and a putty knife, and they worked with those 2 instruments to work with some damaged tiles that had been brought up from Earth and stowed in the cargo bay, and they practiced repairing those tiles and repairing the super hot materials that go on the shuttle, on the end of the shuttle as wings that is exposed to the hottest temperatures. They ran through 2 experiments. They seemed to go perfectly well. Of course, the information and data will be used by engineers to see if the materials will hold up in the event they're needed down the road. But again, this was just a test, but did appear to go perfectly well. The astronauts described the material they were using as like pizza dough. So once again, the first of 3 planned spacewalks on this shuttle mission has just about come to a complete end, a very successful end, and it's a good time for the astronauts to take a break.
John Zarella reporting to us from Texas.
Ce qui s'est passé au moment du décollage mardi. Je vous rappelle que le réservoir externe a perdu une pièce isolante qui n'a pas cette fois touché la navette. L'objectif de la sortie d'aujourd'hui est de comprendre comment tout cela a pu se produire. Bref, petite sortie pour l'homme, grand pas pour la compréhension. Les explications de Lars-Oliver Rehrmann.
Un exercice de voltige à 350 km au-dessus de la Terre, un programme chargé attendait le japonais Soichi Noguchi et l'américain Steve Robinson pour leur première sortie dans l'espace. Les 2 hommes devaient tester des outils et des techniques pour réparer les éventuels dégâts sur le bouclier thermique de la navette. Les astronautes en ont profité pour vérifier si les morceaux d'isolant qui se sont détachés du réservoir lors du décollage n'ont pas abîmé les ailes de la navette. Leur retour sur Terre est prévu pour dimanche prochain, mais la NASA a déjà anticiper un scénario alternatif. Si Discovery est trop abîmé pour repartir, les 7 astronautes devront passer 4 semaines à bord de la Station spatiale internationale, le temps qu'il faut à l'autre navette américaine Atlantis pour rejoindre la station ISS.
Nous avons toujours l'option de rester sur la station spatiale au cas où nous ne pourrions plus rentrer avec la navette. Mais je ne pense pas que cela sera le cas pour cette mission. D'après ce que nous savons, les morceaux d'isolant détachés du réservoir n'ont pas provoqué de dommages signifiants sur la navette. Je ne me ferai donc pas de soucis pour cela.
En raison des incidents survenus lors du décollage de Discovery, la NASA avait suspendu tous ses vols. Mais pour une opération de sauvetage, elle pourrait bien les reprendre.
Der Discovery haben die Raumfähre zu einem ersten Arbeitseinsatz im All verlassen. Sie wollen feststellen, ob beim Start abgebrochene Stücke der Tankisolierung die Außenhülle beschädigt haben. Außerdem sollen neu entwickelte Werkzeuge und Reparaturverfahren für den Hitzeschutzschild im Weltraum ausprobiert werden.
In ständig wechselnden Lichtverhältnissen absolvierten die beiden Astronauten ihr Programm. Die tatsächlichen Reparaturmaßnahmen betrafen weniger die Raumfähre, sondern hauptsächlich die Raumstation. So musste eine GPS-Antenne ersetzt werden. Was die Hitzekacheln der Discovery angeht, so probierten die Astronauten lediglich einige Reparaturtechniken aus. Aber die bisherige Auswertung der Fotos von der Unterseite der Fähre scheinen zu zeigen, dass die beschädigten Kacheln kein Problem sind. Bis auf einige Kleinigkeiten ist die Discovery in einem super Zustand. Wir wissen, sie wird uns sicher zur Erde zurückbringen. Die Kommandantin weiß, dass das grundsätzliche Problem des Shuttle-Programms am Boden gelöst werden muss. Nämlich, dass beim Start immer noch Isolierschaum der Treibstofftanks abfällt. Bis das ausgeschlossen werden kann, bleibt der nächste Shuttleflug mit der Fähre Atlantis ausgesetzt. Discovery-Kommandantin Collins redete Klartext. Bis das gelöst ist, sagte sie, sollten wir nicht mal daran denken, wieder zu fliegen. Die NASA ist inzwischen wieder vorsichtig zuversichtlich, was die Lösung des Problems angeht. Möglicherweise könnte schon vor Ende des Jahres wieder eine Raumfähre starten, heißt es. Bis zum Rückflug der Discovery soll deren Besatzung noch 2 weitere Weltraumspaziergänge unternehmen.
NASA officials say the nearly 7-hour spacewalk was a success.
They've been training for this a long time, and you could tell both with the training that Cindy and her folks have provided and the hard work that they put into this. They did an extremely good job. They were moving as if they've been outside all their life, extremely comfortable and very efficient with the jobs that they did, and I couldn't be more pleased with that.
NASA's still trying to decide whether damage the shuttle sustained on liftoff needs to be repaired before its return to Earth. A California astronomer has found what he believes is the solar system's 10th planet. Astronomer Michael Brown says the object is located 14.5 billion kilometers from the sun and could be 1.5 times bigger than Pluto. Brown submitted a name for his discovery to the International Astronomical Union, but he's not saying what it is. Next at CNN's Just Ahead, I'm Zain Verji, and I'll be back with an update of the headlines. As NASA decides whether damage on the space shuttle must be repaired before re-entry, 2 astronauts completed a spacewalk testing just those kinds of repairs. It may not be as high-tech as you think. John Zarella reports.
If you didn't know they were in space, you might have thought astronauts Steve Robinson and Soichi Noguchi were working on weekend home repairs.
Fairly gluey stuff, so it's a little hard to get off.
For the first 2 hours of a nearly 7-hour spacewalk, the astronauts experimented with techniques and materials that could be used in the future to repair damage to a shuttle's thermal protection system.
I would recommend, if we were to do this for real, to use lots of spatulas.
It was recommended in the wake of the Columbia accident that NASA come up with a way to fix potentially catastrophic damage to heat shielding materials while a shuttle is in orbit.
Now that's a full bag.
Noguchi and Robinson worked in Discovery's cargo bay. Using a caulk gun and a spatula, Robinson practiced repairing gouges in samples of reinforced carbon-carbon, the material exposed to extremely intense heat on re-entry. Noguchi stood by with a cloth to wipe off the tool.
Okay, significant swelling in the gouge here. I'm going to try to take another little bit of it off here.
This test and a second similar one are expected to give NASA engineers a wealth of knowledge about what repair materials and procedures will work in space.
Everything looked great on video, and we can't wait to get it home and take a look at it. They will be doing evaluation of that sample where they can see the whole distribution inside the material of the voids, et cetera, and how well the material hardens.
The spacewalk also provided an opportunity for some spectacular views, including Robinson moving hand over hand down a space station handrail as the Earth passed below him. And just to finish up the day's chores, Noguchi replaced a failed antenna, and Robinson changed out a circuit breaker. The picture-perfect spacewalk was clearly a morale booster for NASA and the mission team. They had suffered through several down days after the external tank problems came to light. NASA also released stunning video Saturday of the solid rocket boosters from the moment of ignition through separation and splashdown in the Atlantic. John Zarella, CNN, at the Johnson Space Center in Houston.
I'm Zain Verji. We're going to be right back with an update of the headlines, followed by World Sport and Terry Badu.
If you can, that'd be great. All right, you're clear. Thank you.
Letzte Vorbereitungen für den Weltraumspaziergang. Spaziergang ist dabei eine Verniedlichung, denn der Ausstieg aus der Raumstation ist für den gesamten Körper ein enormer Schock, an den man sich erst langsam gewöhnen muss. Viele bekommen beim Ausstieg Höhenangst. Die Erde dreht sich um einen herum im Kreise und man hat das Gefühl zu fallen. Man sagt, der Haltegriff an der Ausstiegsluke sei verbogen, weil sich alle daran so festkrallen. Ganz nebenbei brachen die beiden Spaziergänger auch noch einen Rekord. Es wurde der bisher längste Ausflug ins All. Die Astronauten hatten sich beschädigte Testkacheln mitgebracht. Dann probierten sie verschiedene Reparaturmethoden aus. Hier streicht Steve Robinson ein Material auf einen Sprung einer solchen Testkachel. Ein kleines Problem hatte Steve Robinson bei der Entfernung eines Bolzens. Der Astronaut musste seine Position verändern. Dann klappte es.
Well, good afternoon, everybody, and welcome to our mission management team meeting. The meeting just concluded a little short while ago. To my right, or to my left, is Wayne Hale, who is the Deputy Shuttle Program Manager. He's also the chair of the mission management team. To his left is Bill Gerstenmaier. He is the Program Manager for the International Space Station Program. We'll hear a little bit from each gentleman, and then we'll throw it open for questions. With that, I'll turn it over to Wayne.
Thank you, Kyle. It's been a great day today for the Space Shuttle team, as well as, I think, the International Space Station team. We had an outstanding EVA. The crew is performing in just an awesome manner. It's admirable how well they're doing. The orbiter is performing nearly flawlessly. We have no new funnies on our list to look at. Today we tested, I'm particularly proud to say that we tested in space, in orbit, the thermal protection system, two of the methods of repair that we've developed over the last couple of years, the NOAX and the emissivity wash, and both of them performed very well. And I got very good reports from the engineers who watched those tests today on the ground and evaluated the outcome of those tests. They worked very well. We're very pleased, and it bodes well. You know, it is one thing to do tests on the ground. It is another thing entirely to be able to do a test actually in space and get real data in the real environment of how these materials will perform. And we're just very, very happy with all of that. Did a number of tests on the space station. I'll let Bill talk about those. And today we accumulated enough consumables to formally declare that we had the capability to extend the mission a day. And so at today's mission management team meeting, we formally approved the mission extension for one day. This will allow the crews to get more work done during the dock period together, more transfers. They're transferring a number of extra items over and above what they had thought to transfer before. And that is changing our storage plan on the way down, so folks have evaluated that. That work is all coming together. Finally, as we heard yesterday, the imagery analysis from the launch phase has been completed. And the damage assessment on the orbiter is in full swing. Today, a day ahead of our schedule, I am pleased to report that the tile and blankets have been formally cleared by the engineering team in terms of any little damage areas that we had. We showed you pictures of those over the last several days. A few pockmarked tiles, a little gouge at the base of the nose landing gear door, a thermal blanket that had billowed out on the side below the commander's window. All of those items have been formally assessed through rigorous engineering models in great detail and found to be acceptable to fly home as is. The reinforced carbon-carbon, which was inspected, as you know, on flight day 2, they did a few additional inspections at the end of the EVA actually today. The RCC team is looking at those. Obviously there is no gross damage apparent. They believe that tomorrow they will be able to formally bring me the report that says that the RCC is formally cleared for entry. The only issue that they were even interested in was this small black spot phenomenon, which we showed you pictures of the other day. There are several of those that were detected in the scan. They believe they understand the phenomenon. The purpose of the special inspections that they did today was to go look, stop and steer and look very carefully at those areas to make sure they understood that that is a problem or not even a problem but almost a natural occurrence on the RCC. Just make sure they understand exactly what that is. When I left the engineering team, they were confident that that was the case, and tomorrow they will formally, I believe, bring us the clearance on the reinforced carbon-carbon. And that leaves us only one outstanding area to think about, which is not related to impact damage, which are the two little protuberances on the bottom of the orbiter. Today, they think both of those are Ames gap filler sticking out. You know, we've had that problem in the past. This is the first time we've ever really seen it on orbit. The aerodynamicists are doing a thorough evaluation. We will hear their report on Monday. So rather than giving the all clear tomorrow, we will probably be doing that on Monday because we want to allow the engineering team to go through a rigorous process. This is over and above the sorts of things we plan to do pre-flight with the damage assessment. These little gap fillers coming out are clearly not associated with impacts. It is a installation or thermal or vibratory thing that causes them to come out. And once we have that clearance, we will be able to tell you that the heat shield for Discovery is completely ready for reentry. Right now, the crew's in great spirits. I don't think we got to tell them that we've extended the day before they went to sleep, so they'll probably find out in the morning. And that's all I've got. Bill?
Thanks, Wayne. Again, as you said, it's a great day for Space Station. The task that we got done above and beyond what you talked about, where we replaced the GPS antenna that was failed out on the S0 truss, and again, that went very well. We checked that antenna out. It's fully functional and it's operational. Looks good. Got good signal from it. We did a get-ahead task where we prepared the airlock to attach the ESP2 later on the EVA-3, and we put an S-pad device out there that we attached, and we also ran a cable out there that will eventually provide power to that, and that was, again, a great get-ahead task for the crew. We also repowered CMG number 2. We did a patch panel reconfiguration, brought power back to that CMG, and it's in the process of spinning up. When I left the control center, it was about 5,800 RPM or so, and it'll be spun up to 6,600 RPM here probably in the next half hour or so. And again, it looks very good. We got some transfer stuff done today, got a couple of CWCs transferred back and forth, and again, it was just overall a great day for getting things done on station and then getting them done in a timely manner, and it shows how well the teams were prepared, how ready they were executed. We also got 2 little packages in, the missing packages from the airlock, and again, that was kind of a get-ahead task that the crew grabbed those and brought those in at the end of the airlock. So again, that's a tribute to the team and their preparedness and ready to go do the EVA that they got all these things accomplished. The only problem we've been tracking a little bit is we've been seeing some high currents on CMG number 3 when it's in the steering law and the control law. We've seen that before. It's a little larger than we've seen. We may choose to take that CMG offline when we get our other CMGs back online and let it rest for a while until we get to undocked and then track it. It's nothing we see that really concerns us, but to be prudent with our CMGs until we get this one back and understand what the failure is, we may treat it with a little more kindness. And in terms of the extra day, we'll sure appreciate getting that extra day. As Wayne said, we'll do some transfer stuff back and forth ahead of where we were. We've asked for some computers from the shuttle program, a multimeter, some laptops, some office supplies. We'll also be able to return some additional items like some additional cores equipment for the Russians. And then probably most importantly, we'll get 2 CWCs of water from the Russians, or from the Space Shuttle team. And with those 2 CWCs of water, that'll last us about 20 days or so of extra dock time for a crew of 2. So those may not sound like much when you just talk about 2 CWCs, but it's quite a bit of water, and it'll be very helpful to us in the future. So again, a great day, great teamwork on both shuttle and station teams, and I'm really proud of what they've done.
Okay, great. We'll work the front row here. Let's try to limit it to 1 on the first round, and then we'll see if we have time to go back through. We'll start with Bill.
Bill Harwood, CBS for Bill Gerstenmaier. Could you maybe just walk us through the rest of this year from a consumable standpoint? If Wayne and the shuttle guys don't get a flight up before this year is over, can you just tell us how that works out with Progress and Soyuz coming up?
Yeah, again, the plan is we're going to have a Progress at the first part of September 8th, and that looks fine, and it's on track. And then there's another Progress later. We're fine from a consumable standpoint all the way through the end of the year. So again, we're in very good shape. And we had been planning a contingency that if we didn't get any shuttle flights this year, we were fine through the end of the year and essentially doing what we've been doing for the past 2 years, going Progress to Progress. So again, we look very good. We're going to get a lot of water from the shuttle here, which will put us in very good shape. I didn't mention it, but we're in the process of picking up 25 pounds of nitrogen from the shuttle today, and that'll also help top off our nitrogen tanks on the airlock side. So we're going to be in great shape for the remainder of the year.
Go ahead, Craig.
Craig Cavall, Aviation Week for Wayne. More of an engineering question than a process question, if you will, on OBSS. Phil Engelhoff said earlier today that each time you look, you see a little more that you might want to look at from an engineering point of view. If you could address that. And then secondly, I know on day 2, OBSS was pretty much LDRI, but I'm catching up here on LCS and ITV. If you want to discuss a little bit the engineering performance of all 3 sensors.
You know, we got a report that all 3 sensors, not just the LDRI, which is made by Sandia Labs, but the LCS, that's the NIPTEC product, and the intensified video camera, which is kind of a standard camera that we carry on the shuttle. All 3 have exceeded our expectations in terms of the resolution, in terms of their ability to see small features. We are just ecstatic that it has worked out so well. I didn't bring numbers with me, but I do know that when we started this discussion, we were talking about being able to find holes a 1/4 of an inch in diameter. That's what we spec'd out for these instruments to be able to uncover. Later on in the process, we decided that we were interested in cracks 20 thousandths of an inch across, which is a factor of 10 smaller, and these instruments were able to deliver that. And in fact, we can see the very small features of the manufacturing of the RCC panels that are a 1/4 of a mil in size. So the resolution has just been outstanding. The ability to measure depth is something that we used in the analysis of the nose landing gear door tile, and that's just going to be vital to us in the future as we understand our situation on the thermal protection system. The discussion today, as you know, the NOACs material in the human thermal vacuum tests on the ground has sometimes been associated with an outgassing or a fogging of lenses, optical surfaces. Today we saw none of that, which says that it worked very well, and perhaps the orbital environment is more benign from those kind of considerations than the laboratory environment, which is interesting. But before the EVA started, a decision was made to protect the sensors, the LDRI, the ITBC, the LCS on the moon, all three of our sensors, from the potential of NOACs causing degradation of those optics in case we needed to do some further inspections. Today, the orbiter team, the damage assessment team, has said they have completed all their inspections. They have no need to look at anything any further, and we are in fact trying to work in that scan of the pre-damaged dial and RCC components in that test box into a later EVA, so that we get that data, although I have to say that the performance of all those instruments has exceeded our expectations, so it may be that such a test is not in fact required. But to be able to say we've got 100% of our objectives, we probably will go off and put that in the plan.
Hi, Andy Tagg, Fuji Television. I was wondering if there are any decisions made on how to spend extra time on EVA-3 that you made up for by getting more accomplished yesterday. And is there anything that Soichi and Steve are going to have to learn or train on to catch up with your plans?
Let's see, EVA-2, which is coming up day after tomorrow, is the CMG removal and replacement, and that's going as pre-flight planned. There has been discussion of a couple of different options that we would look at. We have about a half an hour extra time available in the normal 6.5 hour EVA for EVA-3, and folks are off looking at a couple of different options. If there is an additional task added into that EVA, obviously there will be some procedure development and uplink to the crew, and no doubt some discussion. You can call that training if you want to. But we have not finalized any changes to that EVA, and in fact, people are still thinking about whether we want to add anything or do anything different at this time.
All right.
I'm in Fox with Reuters. First, I just have a quick clarification for you, Wayne. When you said that the gap fillers is not related to impact damage, tail damage, does that just basically imply that all the other damages that you are looking at, however minor, however cosmetic they are, that all of those are in some degree related to impact damage?
I think it's pretty clear that our thinking that all the little chips, the gouge and those landing gear, we don't have any direct correlation, but it is consistent with what we saw in the ground test when we fired the little pieces of foam or little pieces of ice at tile, and so therefore we think it is impact damage, but we don't have 100% corroboration.
And then a question for Bill. Is it your understanding that the INA emergency clause could be enacted to assure that the station is continually staffed by a U.S. astronaut, or is that there primarily to protect the crew in a life-threatening situation, or if the station has like a survivability issue?
Yeah, I think that's probably a better question for headquarters than myself, since it's more of a legal policy question than a technical type question.
Marcia? Marcia Dunn, Associated Press. For Wayne, I just can't remember the phenomenon on the RCC that you mentioned that they were looking at today. Could you refresh my memory?
During manufacturing, sometimes the coating, which is a very thin coating over the top of the reinforced carbon, develops a little, very small, we're talking very small, fraction of an inch size, I don't want to call them blisters, but that's the best analogy that comes to mind, that a little bit of the outer part of that coating, not all the coating, but a little bit of the outer part can flake off, and then you have this black spot underneath. If that in fact is the phenomenon we're looking at, and the engineering team feels very strongly that it most probably is, then we have got nothing to worry about there. What they wanted to do was just, since this is a test flight, go out and take a look at some of these spots and go over them very carefully. I guess also we did have a few indications on the wing leading edge sensor. You know, the accelerometers there measure the aerodynamic noise as you go through the ascent phase, and we set a threshold, and we said above this point would probably not aerodynamic noise, could potentially be an impact, and then there's another threshold much higher that says we definitely have an impact, and we know that from the testing we did out at Southwest Research, where we fired again test samples against the wing leading edge instrumented wing leading edge. What we saw were about 4 indications where we got an accelerometer reading that was just barely above our noise threshold. And folks wanted to, just for completeness again, go off and look at a couple of those locations to see if there was anything there that would indicate that perhaps a very small piece of foam had impacted. They're really, at this point, trying to calibrate the sensor more than they are looking for impact damage, in my understanding. In any event, the whole report will be there tomorrow. When I left the engineering team, they were all feeling very good about it, but they wanted to have the overnight period to do the final analysis, to have another independent team put their eyes on the inspection video, and we'll get the report tomorrow.
Kelly.
Kelly Young with New Scientist for Wayne. Going back to launch day, how many hydrogen tank pre-press cycles did you have during the countdown, and how does that compare to your limit?
Oh, good. Boy, it's something different to talk about. We got 11 pre-press cycles. That was our limit. Normally our limit is 13. We have lowered the pre-press cycle count on this flight because we wanted some extra margin in case we weren't as smart as we thought we were when we did the thermodynamic analysis of how that pre-press works. We really expected more on the order of 8 or 9 pre-press cycles. We have now gone back and looked at one of the helium valves on the ground system that is involved in this resupply, and we think that it actually cycles shorter than the half a second open per cycle that we planned on. So we think this is an explained condition, although I've got to tell you that's all a preliminary report and I haven't seen the final engineering analysis out of that.
All right. Thank you, Tarek Malik from Space.com and Space News. My question is for Bill about that transfer of material between the shuttle and station on that extra day. Do you have any estimates as to maybe how much in terms of pounds or weight that you would be transferring between the two? And when you are transferring material from the shuttle to the station, is it limited only to operational items like computers and that type of equipment, or are you also looking at maybe comforts for future crews in terms of living items, toothpaste, toilet paper, that kind of thing?
Well, we're in pretty good shape for just kind of normal things, you know, the kind of human things like toothpaste and other things. Those are fine. What we did is we tried to look at things that we were looking for that the shuttle has and carries that we could use. We carry the same laptop computers both on the shuttle and the station, and we've had some failures of our laptop computers where some of the screens have gone blank on some of our computers, and this was an opportunity to get some of those that are not needed by the shuttle team, and we can pick those computers up and then use them in various applications. Some of our multimeters, they're essentially ohm meters that we use for a variety of tasks. They've gone out of calibration on board station for our use. We've been able to kind of back calibrate them, and we think they work fine, but we'd like to get a nice new calibrated one, and there's one available on the shuttle that they don't need that's surplus, so we're going to go ahead and pick that up. We were a little bit short on office supplies, just kind of paper and some other things, some printer stuff that's pretty small, but it was easy to go ahead and transfer. So there's nothing really special or big that we're transferring, and I think that's kind of a tribute to the teams on how well they did planning. I mean, they really optimized this transfer to a tremendous degree, both from shuttle to station and station back to shuttle. You see these differences, but there's not a lot of differences even in these kind of situations. So they've done a great job of really optimizing the transfers.
Guy Guglielmo from the Washington Post. I think for Wayne, or possibly for both of you. Wayne, when you started talking about the extra day a couple of days ago, you said that the feeling was that you were going to try to fit it in between days 9 and 10. Is that where you are? And if so, how come?
Yeah, the plan that was proposed today by the mission operations team that does that planning for us was after the third EVA to add the extra day before we bring the MPLM back over from station. So that you need that, obviously, the MPLM to be on station to do the transfers. So that's a natural point in our lives to do that extra day.
Mark.
Mark Carreau from the Houston Chronicle. I have a question about the clearance. I think I'm a little bit confused. It seemed like what you were saying is some parts of the thermal protection system are now clear. And I wonder if you could say those again and what percent they are of the whole vehicle and what's outstanding and what that percent is. And then I don't know if you've got a scorecard on dings on the different ones or whatever you looked at, but that would be helpful too.
Let's see, what we cleared today were all the thermal blankets, all the tile areas. What we have not cleared are the RCC wing leading edge, including the T seals in between the panels, and then these two protruding gap fillers. So in terms of surface area, we probably cleared 90% of the shuttle orbiter outer surface. The wing leading edge, I don't have the numbers in my mind. And I believe we started out looking at 26 different spots of interest, and the team worked that down to, I think, 4, and this is tile, what I'm talking about, 4 that they wanted to get the focused inspection on, which we did yesterday, and as of today, they've cleared everything.
John.
John Johnson, Los Angeles Times. This may sound like a joke, but I'm actually half serious about it. And that's, what is the EVA Hall of Fame, and what did they do today to qualify for this?
EVA Hall of Fame.
Cindy mentioned this earlier, that complimented them. And what I'm looking for is some kind of assessment of how they did their jobs, comparing that to past spacewalks. Were they particularly wonderful? I mean,
I think Cindy gave you the best estimate. I didn't get to watch the whole spacewalk, and I'm sorry, I can't. No.
I can't believe I'm about to answer this, but I think it essentially just means that they performed their first spacewalks, so they became part of the EVA Hall of Fame of performing a spacewalk.
They literally have a hall over in the EVA building that they put their pictures up in, so I guess maybe that's what.
Frank Mooring with Aviation Week for Bill Gerstenmaier. It's my understanding that you've been working options to present to the international partners for a final configuration for the station with a realistic number of flights by the end of 2010. At what point does a delay in getting back flying again start eating into those options?
Kind of where we are, and what you've heard from the administrator was that we couldn't do the 28 flights in the time between now and September 30th, 2010, and that was kind of based on past performance of the shuttle and the way we looked at it. And we looked at it kind of from a mathematical standpoint, and in that mathematical database, there's numerous shuttle delays for a variety of things, which are very similar to what we're experiencing potentially here and what we saw in the coming days. So I think that the way we're looking at this is we're trying to ensure we have some high probability of accomplishing whatever number of flights that is, and we're looking on kind of past performance and trying to also project future performance to determine what that number is. And that work is still in progress. It's not complete, but it accomplishes exactly what we're going through now. And when we establish that, we'll have a number that allows some reasonable number of delays and then reasonable number of slips and problems that'll come up, because that's where we are with the test vehicle that we're operating and flying. So we're still in the process of doing that, but when we get it done, we'll have a number that has a certain confidence level associated with a certain set of historical background and then also future projections in it.
Okay, let's go around again for those that have follow-ups. Mark? Hang on, we can't. Go ahead, Mark.
Go ahead. Okay. The Mark Carruth from Houston Chronicle for Bill Gerstenmaier. My question has to do with the plans that I think were in place to put a third crew member aboard the station with the September shuttle mission. Where does that stand right now? Will you do that when the next mission flies? Is it all up in the air? And I have a follow-up.
I guess the way I'd say it again is, if kind of a tribute to our planning, is we treated these first two flights truly as test flights, with the majority of the objectives going towards the shuttle program to make sure that we could really understand where we are and how we're operating. And it turns out that we did exactly kind of what we're doing. We're learning some things on the tank that we could only test in space, that we couldn't test on the ground. And so we've learned some things, and we'll go factor those into our thinking, and we'll go fly again, and we'll be ready to go. Again, we'll be good from a consumable standpoint on orbit. We'll have the next mission. We'll see how the systems perform. The sensors have done phenomenal on this mission. I don't work with the shuttle program all the time, but I get the chance to see how well this team has done, and it's nothing short of miraculous. The way that cameras are performing and the teams are analyzing this data and getting it down. The wing leading edge sensors are doing great. The boom is doing phenomenal pictures, as Wayne described to you. The resolution is better than you ever anticipated. So from an overall ready-to-go fly standpoint, this is a huge step forward. So I think we're going to go ahead, and we'll be prepared to go ahead and increase our crew size to 3. Our consumables will be stable at that point, and we'll be ready to go back again with our third crew member on station, I think, on the next flight. But again, I think that's just a tribute to how well all this has gone from all the imagery and all the data. I mean, there's so many things that had to come to place that were first-time operations that are just really super. So I think we'll be okay on this second flight once we get there to increase our crew size.
You mentioned, though, that the strategy basically to keep the station supplied with the absolute minimum and maintain it. You can do that at this point no matter how long the shuttle isn't flying, short or long time, by continuing with this strategy of Russian progress missions. Is that basically what you're saying? Indefinitely you could support the station that way?
In the current configuration with our 2 crew members, again, it's just similar to where we were before. We're still susceptible to some large failure of some component that can only be delivered by the shuttle that we don't have a like spare on board station. We're going to be in much better shape after this flight because our CMGs will be all active, and that's a good situation. We'll have lots of water, which will be a good situation. We'll be better after this flight, but we're still susceptible to some failure where we may have to return the crew. But we'll go, if we have to, we go right back in the same strategy where we were before, of just kind of predicting what's going to happen, carry what we need to on progress and Soyuz, and we can stay in that configuration for a pretty extended period of time, as we just demonstrated.
Go ahead, Bill.
Bill Harwood again with another one. Bill, just to follow up Mark's question, just to put it perfectly clearly to make sure I understand it. If the shuttle can't get there, or until the shuttle gets there, let me put it that way, you don't envision the station supporting 3 people. I mean, you get Thomas Ryder hanging up there and a tourist coming up, and either way, it's going to be 2 people. It's not going to be 3.
Yeah, we would still do just like we've done before. We'll do during the handover, we'll do the 3 crew members with the tourist there, and then we'll plan on augmenting with Thomas Ryder when the shuttle flies again on STS-114.
Irene Fox with Reuters. Also have 2 follow-ups. The first is for Bill. Does your planning also include the restricted launch opportunities, or does that daylight launching need to be relaxed to fulfill the requirements? And related to that is that second shuttle for the CSDS. And for Wayne, I'm just curious if you can kind of take a step back a moment and talk a little bit. I know you're not through with this yet, but is this really a realistic way, everything you've been doing, all this analysis, all these meetings, all these briefings, way to fly a shuttle? Are you going to be able to do this for the next, X number of flights if you need to?
I'll go first with the questions you asked for me, and I guess from our standpoint, we looked at those projections. We assumed first that we had protected for the lighting opportunities on these first 2 flights, and we protected for the shuttle contingency vehicle on the first 2 flights. We've also redone the analysis now, looking at lighted conditions for all the flights, and maybe not all the lighted conditions, so we factored that in some of our analysis. So as we set this number of flights, whatever it is, we're going to look at some number number of contingencies and the way we really think we're going to go fly. So as we change how we may fly, we're going to update our assumptions, put them in the model, and see what we get.
And for the second part of your question, we're committed to flying this vehicle safely. And if this is what it takes to fly the shuttle safely, that's what we'll do. I think we're staffed up for it. One would hope we could look for efficiencies and get smarter. But if this is what it takes, this is what we're committed to doing.
Marcia.
Marcia Byrne, Associated Press, for Wayne. Realizing that the gap filler studies are still incomplete, is there still any thought, even mentioned, about sending one of the spacewalkers down there to sniff and do a little cutting?
Well, that's not off the table yet, but I certainly hope that's a remote possibility.
Craig Cavall with Aviation Week with, again, a couple more engineering on OBSS. Wayne, I guess I'm not clear on why it took till today to decide to hold off on the OBSS survey of the VTO box, since you knew outgassing might occur. Was that related to the black spot issue? And second question on OBSS engineering and manipulator arm for downstream joint angles and arm performance and loads and all that stuff. Have the engineering guys raised applicability to put a human being on that crew member, just from what you've learned this time?
Well, let me see. I'll take the second part. We are going to put a crew member on the end of the boom on the STS-114. That is one of the tests that we want to see is will that long, flexible structure, we know it'll hold a person, but how much will it flex under the kind of loads that you would have with somebody out there on a spacesuit trying to do some work? So we're going to do that test. I haven't heard a report from the engineering team on how the boom and the brakes and the joints have performed, but I got to tell you, from where I sit, no report is good news. So I'm thinking that all is well, and perhaps I'll round up a PDRS operator and bring him with me one of these days, and we can give you names and numbers. Yes, I'm sorry if I didn't quite connect the dots, no pun intended. The black spot, potential for future black spot inspection was what we wanted to protect the sensors on the OBSS for, which is why we didn't do the inspection of the VTO box contents with the sensors today. We still think that it's important to do, and I think we'll still plan on doing it.
Kelly.
Kelly Young with New Scientist. A quick one for Bill Gerstenmaier. Can you give me an idea of how much water one of those CWCs holds?
They hold 43 kilograms or 43 liters of water.
That's around 10 gallons to those of us that don't do metric.
Sorry. That's the international piece of the space.
Yes, it is.
Anybody else have any final question before we wrap up? Mark, way in the back, near his recorder. You can be clean up.
Mark Perot from the Houston Chronicle. I had a final question about what lies ahead for the clearance, and I understand the two gap filler protrusions, and there's wing leading edge, some spots that you want to look at. Is there any way to quantify kind of what you're looking at and where there, so you get all the way to the 100%?
Well, okay. The spots, the RCC panels, wing leading edge, we have obtained all the data. What we are doing overnight tonight is allowing the engineers to evaluate the data to confirm, hopefully, probably, that this is not an issue. So the data is all in hand. In terms of the protruding gap fillers, the aerodynamicists are off doing computational runs to understand what that will do to the boundary layer, when it might trip and transition from laminar to turbulent flow, because that has effects on the tile, the temperatures that the tiles downstream or aft of that trip point C, and it also has effects on the flying qualities or the flight control system margins. They are off running those analyses, and they're going to be going to have those complete for the mission management team to review on Monday. And so there's no further data to get, just analysis.
Okay, I think that will wrap it up.